Did you guys have fun yesterday? Yay! Did you stay out here late? I was asleep at, I think, 9:30. I was out. We're not used to socializing anymore. We need to practice more. Give people a minute to take a seat. And I think we're giving up on the TV logo until after this talk. So, yeah. Apparently I was not visible because it's too dark. Happens the day after, right? Anyway, you're not going to listen to me talk. You have come this morning to listen to David Jacoby talk. So I'm going to put him on stage right away. Big welcome to David Jacoby.
Thank you very much. It's always nice to have the hangover slot. Second day, first speaker. So thanks again for giving me this slot. But it's really nice to see so many people here. I did not expect it, to be honest. I thought people would stay in the hotel rooms or some other places. So I'm David Jacoby. I'm here to talk about Mac OS. If we can get that's not a blue screen, it's a red screen.
No, I think it happens when you kick the scaler down.
Okay. So quickly about me, for those who do not know who I am, I'm a hacker by trade. I hack stuff for a living. I currently work at Kaspersky as the Deputy Director for the Global Research and Analysis team for Europe. So I do APT research and threat analysis and all that cool stuff. I'm a father of two kids who likes Fortnite and Minecraft and is super annoying, but I love them to death. I'm also a sysop still in 2021. Yes, I'm running a BBS on my Commodore 64. Available on Telnet. I also collect VHS tapes, because that's the future. And remember, I was the first one who said that. I also collect retro computers. I love that. But I'm not here to talk about me. I'm here to talk about Mac OS. And why do you want to hack, a Mac? How many people use a Mac right here? Okay, not so many. How many have ever hacked a Mac before? Not so many. How many have ever hacked something else? Okay, cool. So there's a lot of people who never hacked a Mac. The question is, why do you want to hack a Mac? Why do you want to do that? And I have 60 minutes on stage, but please interact with me, because I'm here for you guys, but I think you guys are also here for me, because I want to learn. I just don't want to give. So please interact with me. Just shout out, scream. We don't need a microphone. It's fine. Why do you want to hack a Mac? Yes, sir.
Because rich people use Mac.
Because rich people, then there's not so many rich people in the audience. I think there is a lot of rich people in the audience, to be honest. But that's funny. Is that me? Really? Why? Do we have any other reasons why I want to hack Mac?
The organization is using it.
Yeah. Take over. People use it. So yeah, there's probably Macs in your organization, and when doing red teaming or pen test, you might encounter a Mac. And why skip that? Because you don't have any tools or knowledge how to hack a Mac. You don't skip that. It's part of the infrastructure, so go get it, right? What else? Cybercrime. Ransomware is fun. Makes people rich, right? So they can buy a Mac. Cybercrime, of course, there's malware and malicious code and ransomware for Mac. And also, for the lulz, right? It's fun to hack a Mac. It's fun to hack anything, so why just limit yourself to Windows or Linux or whatever? Hack a Mac if you can. So step one, how do you hack a Mac? What's the first thing that you should do? How do you get access to a Mac? You see it on the network or you see it somewhere else. How do you get access? How do you get how can you execute code somehow?
Plug things in.
Say again?
Plug things in.
Plug things in, correct. You can get access to the machine somehow. But let's see, you can get physical access to the machine, right? I'm just going to skip this. You also, of course, have remote code execution. Some vulnerabilities in the client sides, your browser, whatever kind of software that you're running on the Mac, malicious files, attachments, all this typical traditional stuff that we know. And as Stark said, of course, external devices or just physical access to the machine. I leave it in the hotel room. Someone goes into the hotel room. You forgot it. Someone steals it. You go to the bathroom or whatever. You leave it unlocked. And we know that you should always lock your computer when you go away from it. But we know, as pen testers, people doing red teaming, people do not do that. People just leave their machines. So all this typical stuff that is normal for the same thing, Windows and Linux. It's the same stuff. But Mac has some, let's call them features, right? That allows you to execute code on the machine very easy. So I made a thing I want to show you. Yes, it's funny, I know. So I have this super hacker cupcake thing, right? Oh, shit. Maybe if I change, I don't know. So I have this file, right? A PDF file. Super hacker cupcakes. And let me just see if I have internet. Can the people in the back see my prompt? Yes, you are tired. OK, let's fuck this. So I have this PDF file, right? It can be delivered in any way, email attachment. You can have an iframe on a website or whatever. So when you click it, pay attention to the background, right, to the terminal. Boom, and I have my cupcake recipes. So while you're reading your cupcake recipes, you get a connection back to the machine. But how did this happen? What was the trick here? Some people might have seen what I've done, but this wasn't really a PDF. And this is what's so funny with Mac, is that they allow you to change the icon on an application. So this is just a normal Mac OS app that's executing a shell script. But the shell script is doing a connect back, but it's also opening the PDF. So there's no overflows, there's no magic, there's nothing. But if you pay attention right now, you can actually see that it is an application, right? Look here. It's very small, but it says application. But, and you think, oh, this is so lame. Yeah, but it's super fucking effective as well. Because people does actually fall for this. They do not see that it is an application, if it's delivered on a USB stick or whatever. So that's one way to get access to the machine, right? And one thing that you can check, if you just right-click on the file and it says show package contents, then it's an application, right? So you can just go here. And the funny thing with macOS apps is that if you want to add extra tools, or you want to have something built into, I'm not going to call the binary, but the application, like you want to have an attachment or some other stuff, you just put it in the resource folder. You can put whatever you want in the resource folder. So it's like its own container, right? Containing all the stuff that you want. And you can write a small script that enumerates stuff, and depending on what it finds, it executes the different binaries or whatever stuff that's inside the resource folder. This is super effective. You can put it on network shares around the network, call it financial document, whatever, and people with the Mac will open it, for sure. So now we have access to the machine, right? Now we can do, what can we do? We don't have root. We don't have nothing. We just have a normal shell, right? So after obtaining access to the machine, what can you do? And this is actually what the talk is all about. Post-exploitation on Mac OS, right? After you get access to a machine, as a low-privileged user, what do you do? Put your hacker hat on. What would you do? I know what I would do. Get root. Just instantly, get root. /get root. OK, before I get root, I want to have persistence. Right. So as a hacker, if I do get access to that machine, I want to keep my access to that machine. So if that person reboots the machine or does whatever, I want to have access to that machine. But how do you get full persistence on a computer without administrative permissions? Does anyone know? Autorun. Can you do that? Full persistence, reboot everything without administrative rights. Say again? Bash RC. Do you think Mac users uses Bash, opens the Bash?
Anybody that care about that?
Ah, cool. Good answer. Of course, you can modify Bash RC, but most people with the Mac, they just click on the icons, right? They use the browser, and Mail, and Photoshop, and whatever that they're using. But one idea is to install rootkit. Nah, you can't do that. You don't have permissions to do that. Another idea is to modify the startup sequence, bash RC or whatever. But I don't know if it's super effective. Because you want to have real persistence. You want to make sure that your code is executed every time as startup, right? What else? Modify the hardware. Of course, if you have physical access to the machine, you can modify the hardware. Have anyone ever tried to open up a MacBook? How many times did how many times did you think like, fuck, I don't have that screwdriver? Shit. Yeah. Every time like I want to fix something with this machine, I was like, God damn it, I don't have that screwdriver. Now I have it, but still, you open up and it's just like you can't do anything with it. It's not like the old computers, right? So modifying the hardware, it is possible. But how do you get full persistence on a Mac OS after you got that shell? Mac OS has some problems. Here we have, I'll make the terminals bigger so that people in the background can see. Mac OS has a big problem, which is when you install applications on your Mac OS, some of those applications are installed as you, right? Some are installed as root, some installed as you as your current user. Why is that a problem? If you look here, I hope everybody can see. If I make it bigger, can you guys see in the background if I do this? Can you see? Yes. So if we do this, here we have applications that's installed by me. And I want to point something out. This machine that I'm using right now is fully updated. It's actually my own machine that I use for work. So this is actually my work laptop that I'm hacking right now. The problem is I haven't found a good way to run Mac OS in some kind of VM or anything. I don't really know how to do it. So I'm hacking my own workstation right now. So I have all this stuff, and you can see, I have kids, I have Roblox, I have Signal, Skype, whatever. I have all these applications. Why is it a problem that I have all this stuff on my machine?
You can replace the binaries.
Say again?
You can replace your binaries.
I can replace my binaries, exactly. And the fucked up thing with Mac OS is that the applications that you have put in your startup sequence will just go to the path of the binary and execute that binary. There's no checks, there's no nothing. There's absolutely nothing checking that binary. I found one application which I don't want to call it backdoor, but that I couldn't use this trick with. One binary. That was Spotify. Spotify checks that the binary is called Spotify. So if I rename that to Spotify 2, the execution flow breaks. All the other applications that I tried, it worked with. So if I, for example, go to something that starts up Dropbox, for example. If I go to Dropbox, Contents, Mac OS, I have my binary called Dropbox. Imagine now that I have my command shell, and I'm in here, and I'm just like, fuck it. I'm going to rename Dropbox to Dropbox2, and then I'm going to create a new binary called Dropbox that does exactly what I want it to do. This is, I don't know why this is even possible. But this gives a lot of leverage to persons who do get access to the machine somehow. So no matter what kind of technique that you use to pop a shell on a Mac, this is one super easy way to get full persistence. I'm actually going to change it back because I actually use Dropbox. But how many people knew about this trick, that you could actually get full persistence just by replacing the binary with your own code? Good. So that is actually pretty crazy. But what else? Now you have full persistence on the machine. So every time the user reboots the machine or whatever, you will get your shell back, okay? What else can you do? I'm giving it to you guys. Collect local information. There's so much shit stored on a Mac that you can collect. There's insane amount of data. And during one test that we did, I can't really talk about it, but we did one test, and we were like, we want to extract as much information as possible from a Mac. And when I started to look into like where is the information actually being stored, and Mac OS, they love SQLite databases. They love it. It's the best thing ever. Everything's stored in SQLite databases. So just as a fun thing, I was like, okay, can I harvest emails and contacts and fun stuff? So I made a small script that dumps out your contacts from your calendar. So it's just email addresses, right? But you know, email addresses has a little value on the black market, can be used for, you know, OPSEC and that kind of stuff. But it's also dumping attachments from the calendar. Teams invites and, you know, all this, you know, Google Drive links and all that kind of stuff is inside the calendar. And this is kind of useful, you know, because if you get a link that's private, but it's in your calendar, anyone with access to the machine can get it, right? But that's, you know, I know it's kind of boring. But you know what else is stored in SQLite databases? Cookies. How many uses Teams? Huh? How many of you authenticate every time you start Teams? The application. Right? None, right? Because there's, you know, single sign-on cookies here. And this is, of course, stored as you. So you can have that information. And now, another question. How many of you, if I would have access to your Teams chat, the chat logs, would I get other kind of sensitive information, usernames and passwords or whatever? Most likely. So a lot of people say, well, you can't just have the cookie. You need to come from the same IP. There's other checks that's being done. But hey, Mac OS has another cool built-in hacker tool that everybody uses called SSH. And then what can you do with SSH? You can do a reverse SOX proxy from the machine. So I can still come from the hacked machine using the cookies that I just stolen. And there's more cookies. It's not just Teams. There's other fun stuff, you know, Slack, Steam for people who like games. So there's a lot of information that you can collect. Let's see how we are on time. Oh, we're good, I think. And phishing is something that's, you know, very wide. People use that to collect information. So we still do not have the user, we still don't have the password locally on the machine, right? We're just using this shell, and we can just find the information, but we cannot do any other stuff. We can't unlock stuff. So sometimes you actually need to have the password. Because why is the password so important on Mac OS? The username, the user's password is extremely important. If you can get hold of the password, that machine is fucked. Say again? No, root doesn't make a difference on a Mac. Who said that? The keychain. So how do you get the password for the local user? Another fun thing with Mac OS, do you know what that is? That you, as a local user, can get your own password hash. Imagine that you're on a Linux system and you can read etc shadow, but you can only get the entry for your own user. That's basically how it is on a Mac. You can get your own, and it's not that kind of password. It is actually the hash to the keychain. And here you can see this is the entire keychain. All the stuff that's inside the keychain, but the fun stuff is locked, so to say. It's encrypted. So I need the local password to decrypt the keychain. But the password hash to the keychain is available. That one is fine. Here it is. That is the hash to the keychain. So if the user has set a bad password or a weak password on the local machine, you can crack it within minutes, right? And once you've cracked the local password on the machine, you can unlock the keychain. And the keychain is extremely powerful. There's more than one keychain. There's a system keychain, there's a login keychain, but just imagine all the stuff that you ever saved on the machine. We're talking about email accounts. We're talking about Wi-Fi passwords. We're talking about credit cards. We're talking about browser passwords. Everything is stored in the keychain if you're using their own tools. Chrome and Firefox has their own so-called keychains where they save passwords. But the encryption key to those keychains or password databases for Chrome and Firefox is stored in the macOS keychain. So that's actually kind of fun. So getting access to the keychain is vital, right? So we take this, we create a file, we run John the Ripper on the file name containing the hash, and we have the password. Hack the planet. Now everybody can hack my machine. But hack the planet is my password to the keychain on my machine right now. So with that password, I can do a lot of stuff. And there's a few people that I know that says, well, I'm not even using a password on my machine. I don't know why this is happening. I'm not using a password on my machine. I'm using my fingerprint to authenticate. I'm not even using passwords. But Mac OS is not fingerprint or password. It's always both. So when you install your machine from the first time and the password that you set on your account, that is the password that is still available. Your fingerprint is also available, but also the password. So if you just put a crappy password in the beginning and say, fuck it, I'm going to use my fingerprint, but you never changed that bad password from the beginning, that is still available and it can still be used. And I do, if I want, hack the planet. I can get root. But do I need root? What should I use root for? I can access basically everything that I want without even having root on the machine. Right? But there's more ways. So this is, imagine that you actually have a good password. Imagine that you have a password that takes a long time to crack. Because cracking the keychain, it doesn't go super fast. It's a pretty strong encryption, right? So if you want to do something else, how would you obtain the local password from the Mac? Trick the user, how would you trick the user to enter the password?
Pretend to be keychain.
Okay. Yeah, look at this. We're on the right track, right? Look at this, fake prompt. For all the Swedish people. It says, new software update available, enter your password to upgrade, and BankID is open. Okay, my password is it should say bought as sexy, but it's not. But that's pretty fucked up, right? That you can mimic basically any application on the machine and get a pop-up saying, well, there's an update available, you need to enter the password. And you might, it's phishing, right? So there's no guarantee that it will work. But if you're 100% honest, I know that this is absolutely the wrong audience to ask, but would you enter your password?
Fuck yeah.
Fuck yeah. One. You would. That's cool, right? So userland phishing is pretty easy on Mac OS, right? And some people think like, oh, I wouldn't fall for that, or that trick is so easy, or whatever. But again, it's super effective. It's like any phishing. Of course, if I send you one email saying it's from Skatteverket, or it's from PayPal, or from whatever, just one try, I would probably fail. But that's the powerful and good thing with phishing, is never just one try. They keep on trying until the user fucking clicks on the link, opens the attachments, enter the password. The same thing with userland phishing. It's not just one try. Keep trying. Keep trying different applications. Be a pain in the ass for the user who's there. Just spam them with pop-ups until they're like, fuck this. And they enter the password. So now we have the password. We can collect information stored on the machine. We can do other cool stuff. We can establish remote access to bypass all this cookie stuff, right? So if there's an IP check, I can have my reverse SOX proxy running. And another thing is, people might say, well, I use the password manager, or I have other mechanisms to secure my stuff. I don't store everything in the keychain. I have password managers. There's another really stupid thing with Mac OS. And I also want to say that the stuff that I'm showing right now is native on Mac. I'm not running any funky monkey tools available on the internet. This is native on Mac. Everything that I'm doing. So all the tools, all the scripts, all the stuff is available on every single Mac in the entire world. So, exploiting password managers or something else, right? Let's say that you do have an email somewhere, or you have, whatever document with usernames and passwords. You can, of course, have access to that document, but imagine that you do not have access to the document, right? You just copy and paste from a source. I want to show you something that's pretty crazy according to me as well. So I'm going to select Matthias is sexy. Let's imagine that is my password. Paste demo. There's a binary on Mac OS which pastes the content of the copy and paste buffer. That's the entire function of that software. It pastes the content of the cut and paste buffer. And this script that I'm running right now, I think it's running every 5 seconds or whatever. Imagine that that's running every second, or every half second. It's basically a keylogger, but not right. But it's just, it's stealing everything that you copy and paste everywhere. So if you copy and paste whatever kind of password, any sensitive data, whatever, I will have it. So if we look at my log file right now, it says Matthias is sexy. Right? We can do another, just for fun. We keep that one running. Remember, I copy and pasted. I copied Matthias is sexy. Let's just copy something else, right? We'll take this string, just copy this one, like this. I do nothing. Let's look at the content of this log file right now. Imagine that that would be running in the background of your machine. And the fucked up thing is, you can't detect this. An antivirus can't detect this, because this is a Mac OS application. It's there by default. It should be there. It's not a, some hacker tool that's been downloaded from the dark web. It's there. It's just there. So it's very easy to get access to sensitive data on the Mac. So with all these different kind of tools and techniques that I've been demonstrating right now, it's basically game over. If you do get code execution in one way or another on the Mac, it is game over. And as far as I know, you have to correct me if I'm wrong, there's no similar way that this can be done on, for example, Linux or Windows. I'm not an expert on Windows, but I know that there's a lot of people here super good at Windows. The stuff that I just showed, is that possible on Windows by default without, yes, sir?
Actually, the copy-paste thing,
Yeah,
that's broken.
that's broken.
I know because I wrote a script on it, and about a week later, they put it into Deep Defender.
Oh, okay.
Second thing is the question. The other thing is the certs.
Yeah,
Do you have the private keys in the keychain?
yes.
Okay, so the private keys are out into virtual space ISO.
Okay,
So yeah, we have them in a TPM.
cool. Say again? Upprepa. Can you say that all again and very loud?
So the trick is that we go ahead and we put the well, for one thing, the first thing was the copy and paste. That thing we put a detection in to figure out if people were pulling it a certain rate out of the clipboard. Because there's a function that's built into the OS to do that. And then the other piece of it is in terms of the keychain, there's a thing for, if you were to talk about private certs being in a keychain, there's something that basically, well, all our private keys for certificates are actually stored within TPM.
Okay. But the paste stuff, right, that is, there's no tool for it.
It was working till about 1.5 years, 2 years ago, but then I wrote
okay.
a PowerShell script and they started catching it in Defender.
Okay, but you can do it with like PowerShell or whatever.
Yeah, it's something that we knew about, but there's a function that is get clipboard info that's built into PowerShell.
Oh, okay,
But
sexy.
yeah, but
Sexy. Cool, thank you so much for your comment. Very useful, thank you. So imagine, let's just go back in time. So you do have code execution somehow. You open up the attachment, you click on a link, somehow you get code execution. You get access to the machine as a local user. You can break not breaking, but it's just very bad ACL on the installed applications. You get full persistence. When you have full persistence, you can do userland phishing. You can dump the keychain hash. You can crack the keychain hash. And you can do a lot of cool stuff. What else? What else can you do? Now you have all that stuff. I know it's basically game over because you have root on the machine and you have the username's password, you have the keychain. And the cool stuff with this attack is that everything that I'm showing when it comes to cracking hashes or stealing data or stuff like that, that can be done remote as well. You don't have to do it physically on the machine. You can just steal those files and analyze those files offline. So you don't have to be connected to the compromised machine to do all that, right? The keychain, you can just steal it and analyze it offline. All the SQLite databases, same thing. But then, this is not specific to Mac, but the stuff that I'm going to talk about now is like browser security. Because, when you do red teaming and you do get access to a machine, one of the first things that you should do is try to extract all the stored usernames and passwords inside the browser. I know that there's a lot of people say, I don't store passwords in my browser, but there's more people who do. It's super effective. And if you do get access to stored usernames and password is basically the holy grail as well. And the master key on Mac for those databases, for Chrome and so on, that key is stored inside the keychain. So the browser, if you ask me, is basically one of the most used password managers out there. It feels like people use the browser as a password manager, right? And it's fine, but I want people to be aware of how easy it is to decrypt and get access to that information. And also, session cookies is super valuable. Why would you even need the password in some cases when you can just have the session, right? So what we've seen on the black market is that people do not just sell password dumps. That's what we've heard about, for a million years, people buying and selling password dumps. But what about session cookie dumps? Oh, you're logged into whatever kind of resource right now. Oh, I want to have a session cookie. Here we go. And on the machines that the session cookies has been stolen, on many of those machines, not all of them, but many, you also have a Trojan, which is basically the SOX proxy, because you need to come from that specific IP. And in some really advanced databases that we've seen, you also include the user agent information. So you have the user agent information, and you have the IP number, and you have the session cookie. It's fucking game over if you have that. There's not so many more checks that you can do. Say again? Oh, okay. And of course, browsers can be Trojanized with different kind of applications. Me and Franz Rosén, I don't know if you're in the audience, we did a cool thing a few years ago about some extensions that's basically stealing session cookies as well. If you do get access to the browser, it's super effective. And the browser is not checked that often in, for example, antivirus engines. Of course, they will check some Chrome extensions and stuff, but it's not like when you try to install a rootkit or you try to modify, the system behavior on operating system. The browser is still a safe place to do stuff. So then you can do all these privileged attacks. You can dump the passwords. You can do that offline. You can dump the system password, which is Wi-Fi, encryption keys. If you have established SMB connections, stuff like that, it's all stored on the machine. Installing kernel rootkits, question mark. Why would you even want to do that? Why wouldn't you go through the hassle to try to, bypass signering? What's it called? The signing of binaries and kernel modules. It's a hassle to do that. I mean, Mac and Apple, they've done a lot of good stuff as well. They have their secure boot. They have, they've added a lot of security mechanisms. But I'm surprised that people do not really talk about this userland simple stuff, because in the industry and in general, people still think and have the opinion that Mac OS is a more secure operating system than, for example, Windows. I know that this is not the audience to have that argument, but we need to think about, in general, the people who are using the Macs, the people who are, who don't care about security. They think Mac OS is better. There's no such thing as viruses for Mac. We've all heard it, right? But there are. It is. The stuff exists. You have Chrome on Mac. You have Java on Mac. You have, WebKit. It's all broken. We've seen all the CVEs. We know it's broken. So there is a lot of stuff. And I think that we will see much more ransomware attacks targeting Mac OS in the future because of this security model as well. It's super effective. You have access to everything. And it's very easy to hijack the machine. Change the password so you can't even unlock the keychain because the ransomware has already changed the password to the keychain. Lateral movement. You hack one machine with all those credentials. How difficult do you think it would be to connect to other resources on the network? Super easy. Hacking a Mac is fun and it's super easy. But there is some limitations. I just want to say that. Some of the demos that I've shown, they will work by default, but there are limitations. There is a feature similar to what's it called? The prompt on Windows, the UC prompt, the UAC, the UAC prompt. So when I, for example, have a shell on the machine and I want to access a specific folder, I want to list the content in a specific folder, for example, there will be a pop-up saying, this program want to have access to this specific folder. It's not valid for every folder, it's valid for some folders. But the difference between Mac and Windows, for example, is that it's basically just one OK button. It's OK or cancel. You don't have to enter a password, you don't have to give it permissions or anything. You just say, if you say OK, it is OK. And the other thing is, it's OK and it will be OK forever. That prompt, you'll never see that again. If you gave it permissions once, that's it. So there are some limitations. Like if I, for example, try to do something, there will be a pop-up, as I said. But you also have to be persistent. You just keep going. And root is basically not root on Mac OS. You don't really have, of course, root is fun to have, but there are policies locally on the file system which prevents you to do stuff, even if you're root. You don't really have to go for root on a Mac OS machine. It doesn't make a difference. The stuff that I've shown is not, I didn't even use root. I have I can use sudo, right, to obtain root access, but I don't need it. Installing kernel rootkits, it's not super easy, even if you're root. It's possible, but it's not worth the hassle. You don't need it. And again, ransomware is not a limitation. Oh, this is old slides. Sorry, they should be removed. But there are some limitations that it's just, so easy to bypass that I don't even want to call them limitations. But to an audience like this, I just want to say that there will be some kind of interactions with the user. But from my experience, it works. It still works. So how to fix this, right? What do we do? Mac OS have all these features, it's all broken, but what can we do, right? So another thing, when you buy your Mac, you're asked to create a user on that machine. That user itself is, I shouldn't say a local administrator, because it's not root, but it's somewhere in between. In the guidelines, it actually says that you should create a third user, because the second user, which is not root, the second user is the user that you create, is the local administrator, basically, on the machine. That is the user who can run sudo. So if you create another user, which is your third user, which is actually the low-privilege user, you cannot run sudo. But you can do all the other stuff that I've shown you. So you can, because you're in the context of your own user. You're not breaking out of context. You're still the context of your own user. But of course, the password to your machine, to your keychain, should not be weak. It should be strong, because if someone can get access to your machine, you're fucked. Simple as that. My best advice, don't get hacked. Right? And as you all know, storing passwords in the browser is really bad, because you'll get hacked again. Questions, and thank you.
Thank you, David. So you woke up this morning and thought, okay, I see a surge of macOS hacks coming in the future. I got to warn people.
No, so this, I don't really know how much I can talk about. This stuff that I found during when we was filming this SVT series, Hacked. and we were forced to hack Mac OS machines, and I've never hacked a Mac OS machine before. So, you know, we were filming the next day, and we needed to have, you know, some way to execute code, getting persistence, and also getting all the information. So I started to look into my own machine, and that's why I found this, and I was like, oh, this is bad. I haven't seen anyone else talk about it, even if it's sometimes, you know, I feel like, oh, this is not something worth talking about, but I haven't seen anyone else talk about this. So I was like, okay, we did it in the TV series, and then I thought, well, maybe it's something for SecT. Because I know there's a lot of people doing red teaming and pen testing, but
Yeah, I mean,
you know, but what about Mac?
Are people ignoring the Mac OS boxes when they're doing pen testing? Seriously? No, I'm asking, I mean, audience, how many people just ignore them? No one's going to answer.
No.
It's Friday morning.
I always have
This is like very, it's like, no, we wouldn't.
No, but I thought the talk would be fun because it's not Linux, and it's not Windows, and it's not IoT, and it's not SCADA. You know, it's just something else. It's not web either. You know, it's just, I haven't heard anyone else talk about it, so hopefully someone learned something new. I did it when I did my research, at least, because I had zero knowledge about Mac OS. Zero.
That's good. I mean, I'm not a Mac OS user, so, but that was very
Actually,
interesting to see.
we have quite a lot of questions from the audience, and actually my reflection as well is if you're looking at any hacker conference, you see quite a lot of people using Macs because they're nice machines, but
They're safe.
because they're safe and there are viruses for them. But one of the first most relevant questions from the audience, what about this new, you can only run signed code on OS X?
Yeah, but this is not code. This is shell script and built-in applications that's already on the Mac.
So even though if you said like, you install this.
I'm not
signed
installing anything. That's the case.
So
Everything is by default on the Mac OS. So the code is signed already, so to say.
So you're just changing the symlink basically to the signed binary.
No, see, that stuff that you can only run signed code is not working for the applications that you install yourself, because you already installed that application. So sometimes when you download, you know, the DMG or whatever from the internet, it says, do you really want to run this installer? You download it from the internet? Yep, fuck yeah, I want to run this installer. Once the application is installed, you can do whatever you want with the applications, like rename it and so on. So, you know, it's no problem. The binary is already approved in the installation process. I'm not installing anything new. And I think that's, you know, what
about the password pop-up that you did for Bank ID?
Yeah, that is. I can show you the code.
Yeah?
It's a built-in script called OS script. So it's a fake prompt.
Oh, okay.
Yeah.
All right.
This is it.
All right. That makes it easier.
Yeah. So I mean, if people want to have these tools, I'm happy to share them. There's no magic. I mean, I'm not lying. You know, it's all easy stuff. It's just simple shell scripts that does everything.
Yeah.
Okay, got another relevant question. What about the actual fingerprints? How are they stored, and are they hashed, or how are they stored on OS X to unlock the keychain with?
Yeah, they're also stored inside the keychain, but you know that if you represent, you know, the string that represents your finger is a very long blob, you know, that is very difficult to crack. But since cracking the keychain hash is based on basically word lists, so that's what I said. If you have a super strong password, it's very difficult to crack the keychain. That's why you want to do this userland phishing, for example. But cracking the fingerprint is, I shouldn't say impossible, but it's basically impossible. You can get the fingerprint data if you're able to unlock the keychain, because you can read it in clear text, but that requires the password or the fingerprint. So if you need to have either the fingerprint or the password to unlock the keychain.
But you probably can't recreate the fingerprint from that data anyway. It's probably
No, it's just a blob.
Yeah.
It's just, you know, it's just a blob. It's just ASCII characters.
Another question is like, what actually decides on OS X which applications will like start automatically when you boot up the machine again?
There is a login. I can show you. There is in the login profile. Let's see, users. There's two different ways you can list that. Let's see, you have login, hack the planet. See, login items. you have that login items that you can list, for example. But then, for example, one funny thing is that, for example, Spotify can run on boot, but I haven't found where the startup sequence is. So for Spotify, I don't know. But you have this login items, basically your bash RC or whatever you want to call it. Like this is local on the machine.
But for persistence, you want to pick something that doesn't update very often, because I guess when you update it, it's...
Yeah, so that's a very good question. If you do update that software and it replaces the binary, your code will, of course...
And you lose persistence.
Yeah.
You do it to all of them.
Yeah. So I actually wrote, maybe I can share that. I don't know if I can, but I wrote basically, I automated this entire process. And so it will find all the applications that you have permissions to modify. Then it will double check that against the login items, choose that applications, and automatically replace those binaries and do a backup of the first one, because you want to keep that, right? So automating this is not super difficult. But yeah.
Okay, final, I think very relevant question. What can you do as an average Joe if you're not super security aware and don't want your Mac to be compromised?
Well, one thing is, of course, create that other account and, have a strong password on your keychain. That's something that's important. You need to protect your keychain, because if you do get access to that, you're fucked, right? But then, do not click on stupid stuff and update your software and, the traditional stuff that you have to do on any machine, right? That's what you can do. But this talk was more about if you do get popped, if something happens, what can the attacker do, right?
Okay, then I have a question. Are you guys, like from the antivirus community, when you ran MacVirus, are you putting, like, checking for these kind of things as indicators of compromise?
Of course. So
Now you do.
yeah, exactly. Since I did this research, my boss was like, well, why haven't you, written this document? Why haven't we added it into the product? I was like, fuck, I should never have told you that I did this research. So yeah, now we have to do it. But it's like what you said. So you had this feature with the cut and paste buffer. Suddenly Microsoft is adding it into Windows Defender. And I think, the AV industry, the security industry should do the same. There should be checks. Like maybe you, for example, with your password manager, maybe you can check, see if there's something running in the background, because that PB paste is the binary that pastes the buffer. If that's running at the same time as your password manager, maybe that's a bad idea. Just kill that process. Fuck it.
Okay, thank you very much.
Wait. I have one more question, because I'm not sure if it's my ignorance or if I just missed something. Did you say that you see people selling session cookie dumps?
Yeah.
Yeah, okay.
Yeah, absolutely.
I just missed that part.
Okay, yeah.
Actually, we had a question of that as well, because session cookies, by the definition, isn't a session expiring fairly shortly, or is that changing overall that we have longer sessions, or why do you see that being?
So, as you know, some sessions have an expiry date. Some so-called super cookies, that's what the public call them. Facebook is one of them, and Teams has them. They do not expire. They have like a year or 2 years or whatever. They expire way in the future. They don't expire within an hour or something. So they're both. Of course, some session cookies are not valid when you get them, but some are. So it depends on the cookie. And this
Little checkbox, remember me, right? Everywhere.
Yeah.
Yeah.
Oh, okay.
Oh. I can't hear you.
Wait for the microphone.
Yeah.
Hello. So my question is that when you already have, like, say, userland access, how hard is it to get access to hardware? You see people having, like, taped their video cameras and people taking out their microphone connections, but since you say that userland access is almost the same as root access, you don't really need root access. Let's say without a password, can you access the peripherals, the webcam, the microphone, etc.? And also, I guess root access should give us access to the hardware as well.
No, so that's a super good question. So there are some programs that's already approved by Mac OS, which has access to, for example, the camera. If you, for example, run Skype, Skype will access the camera without, you already gave it permissions once. So if you, from userland, use those built-in applications that have access to the microphone or have access to the web camera, you can get that. But if you want to have access with your own code to the hardware, that is much more difficult. And since Mac OS has this code signing, not even root can do that. You have to do more tricks to get access to the hardware. So root is, as I said, not root. It just doesn't give you automatic access to the hardware due to this code signing stuff. Hope that answers your question.
All right. So finish with questions? All right.
I'm available every day, all day. So
you're going to get interviewed. Thank you very much.
Thanks for listening. Thanks.
And I think we have half an hour coffee break now. Is that? Let's check the schedule. Magnus on stage 10:30, so half an hour coffee break. I'll call out for you.
So? Ah, he's talking to me.
So, welcome to Säkerhetspodcasten at SecT. And now we have listened to your awesome talk here, Mark and
Aaron.
Aaron, sorry about that, I forgot your name. You were talking about fuzzing drivers, which is, of course, a very, very hard topic. And you sort of explained how to automate the process to cover a lot of ground without doing too much of the legwork. And so, could you just briefly tell us how do you start taking on something like that?
Well, I guess one of the things that drives us and the whole humanity is well that we're lazy and we want to work as less as possible. Other than that, we've gathered quite a lot of knowledge about Windows drivers in general, and not so long ago KFL came to existence. So the natural thing for us was to see how can we use the knowledge we have both on fuzzers and on drivers, and of course attack them as a target. Of course there are like many problems on the way, but at least we had a point to start from.
Cool. But I mean, starting with fuzzing drivers, I mean that's really hard because I mean you get blue screens and then you're done.
Yeah, but blue screens are a good thing with fuzzing drivers, because if you manage to find the blue screens, it means you find a bug.
Yeah.
Later on, you understand the implications of the blue screen, and if you can exploit it further on to run your payload in the kernel or do some other types of elevation of privilege attacks. But if we got a blue screen, we are very happy.
Cool.
So I missed the beginning of your talk due to crew duties, but is my understanding correct that you built a big test harness upon KFL and some other things to fuzz drivers? That's basically the concept here.
Yeah, correct. Take the knowledge of a manual reverse engineering and the knowledge of how the kernel treats drivers, and specifically speaking the IO manager, and later trying to generalize it and do some things automatically.
And the end game here, fun and profit, or are you hunting for bug bounties? Is this more for the fun of it?
Mostly fun and profit.
Yeah.
We do research for white hat perspectives.
Yeah.
Mostly.
Yeah. So you outlined your methodology and how what you're looking for and when to sort of step away from something. Is that no, we're done with that. We're not even going to look at that. But I mean, the work in sort of understanding what you should be looking for, I mean, that must have been very tedious work.
Yeah, we needed to understand how drivers work in a very deep level in Windows. And this is also holds merit to other operating systems as well.
Yeah.
If you try to find bugs in them.
Yes, because I mean, before you start automating, you need to understand the manual processes.
Of course, and we just showcased in our talk around 5-6 different bugs.
Yeah.
But there are a lot more, like there are multiple different things that can go wrong in the kernel.
Yeah.
So you must have a very keen eye, also as a researcher and mostly as a developer, if you want to find those bugs.
Right.
So let's say that you wanted to look for kernel security bugs and maybe use your test harness or something. Is there any logic to which would be the easiest or most interesting drivers to find bugs in, or is it just pick at random and are some much easier to test?
Yeah, there are probably some guidelines that could help you. Well, first of all, it's important to choose the platform, because if it's a closed source platform in its nature and the drives are closed source, it's more likely that no one tried to fuzz them and look for vulnerabilities in the first place. So that's one thing that could help you. Another thing is choosing the specific natures of the drivers itself. So one of the things we want, which is crucial to us, is the ability for an unprivileged user, a weak user, to be able to interact with those drivers. Other than that, we want to look for drivers that do a lot of stuff with inputs and parsing.
Besides that, we didn't cover it because we did not have enough time. We can look for suspicious APIs like your memset and memcopy APIs, that in those places most of the bugs actually take place.
Yeah.
So if we wrap everything together, these are the top contenders. And we just looked for mostly things that you have out of the box that are not third party. Because as you go further away from Microsoft standards, the quality of code is a lot less good than Microsoft's own.
And one thing that I was thinking about in your methodology, you used feedback loops into your fuzzing engine to sort of target your fuzzing in an intelligent way. And also you were talking about grammar, that you were using sort of the constraints of what the input should look like. One question that popped into my mind regarding grammar, wouldn't that potentially limit the fuzzer?
So it's a great question, and I think that's like the main challenge with grammar is you do want to point the fuzzer to the right direction, but you don't want to make it so that you miss a lot of important stuff. So that's part of the reason we did not want to use the classical method of structure of aware fuzzers, because again they're too limiting, and the reason they are too limiting is that they're not very flexible. And the method we employ, which is based on some of the latest additions to KFL, they actually allow you to mutate and change the grammar as you go. So for example, even if at some point you created such input that made it so that you missed lots of important parts, not all is lost. It is very likely that in a few more iterations later, once you see you don't get more code coverage, you will change your strategy, and then the grammar can adapt itself.
Yeah.
Also, if you combine the two of fuzzy and smart grammar alongside some manual reverse engineering, you can improve your grammar on the fly mostly.
Right. One thing that I'm not into kernel stuff, but one thing that I couldn't quite wrap my head around was, how did you detect code coverage?
Oh, so the detection of code coverage, it's pretty much built into the early versions of AFL, and as far as I'm aware of, it did not change much. But the main idea behind it is to use a very small optimized structure, such as a bitmap, which is basically a multi-dimensional array. And each cell in that bitmap, it represents a hop from one code block to another. And the actual value of the bitmap is how many times you encounter that hop. So the idea is that by hooking the code blocks themselves, the fuzzer gets an update each time it discovers a new code block. So the bigger the bitmap gets, the more code coverage.
So it's basically a state machine, but in our case, because we dealt with kernel code, we needed to use Intel PT.
Yeah.
And of course, there is an AMD counterpart if you have an AMD machine, but we have Intel.
Cool. Yeah. Awesome. Well, would you guys, have any sort of tips to young people or budding security engineers who want to get into kernel mode fuzzing or driver fuzzing? What would that be?
So I think, first of all, many of the blocks are a little bit mental, because it sounds like both fuzzing and drivers, they sound scary.
Yeah.
So maybe that's one of the things. Another thing is that what's really cool about drivers, and specifically ioctls, that pretty much any operating system had them. Windows has them, Linux has them, Android had them. So once you understand the gist of it, and you understand the methodology, especially if you have a way to automate it, that you can do like a lot of work at some point, but then you can employ much of the same setup against other targets, which is kind of cool in my opinion.
To strengthen this point, the main vulnerability area that we've encountered, and also in bug bounty or in bug hunting in general, is how things are being parsed and used. So if you know that an I/O communication channel also exists on different operating system, then this is the place you start looking for. And you can do this by reading a blog, viewing a talk, or just disassemble some random driver and see how things go with a debugger. That's how I suggest people to get into this type of research.
Yeah. Also, I can imagine that during your work you've come across quite a lot of serious bugs, and still you must have only sort of scratched the top of the iceberg, so to speak. Do you think there will be like a flood of new discoveries within drivers? I mean, we've seen a couple of very public ones lately, but what do you think about the future of drivers?
Well, of course, it's very hard to predict, but I think it's quite plausible to assume that. And again, because of the fact that many of the driver code is legacy code. Yeah. So it means two things. One, it's quite old. Before the programmers were more aware. Hopefully they're more aware today. And the other thing is that it probably did not go through modern CI/CD QAs like fuzzing on the fly and things like that. So currently there's still sort of a barrier to do it, whether it's technological or again mental. But I personally do believe that once this barrier gets broken, it will, we'll see more of those.
Additionally, driver developers are pretty rare breed. It's actually, I reckon it's more difficult to develop a driver properly than to find bugs in it.
Yeah.
And some of the guys are getting older and changed positions, so it's very difficult for a company, even a company that is willing to pay top dollar, to get a decent driver developer. So it increases the chances.
So that's kind of a miserable outlook.
Depends on your point of view.
Yeah, exactly. But let me turn that question around then. What would your recommendation be to someone getting into driver development then? Because it's hard to do it right.
That's a great question. Yeah. You need to understand the nuances of data like management. Yeah. How to treat user parameters, and always assume that the user is malicious.
Yeah.
Like the first step that we needed to do in order to talk to a driver is to open a handle of it. If your driver does not need to talk with regular or limited users, don't allow it. No. Then you eliminate completely the entire risk from low limited users, because as Microsoft says, if you're an admin, you can do whatever you want on your machine, and it's not a really terrible thing that you have a bug in the driver. Yeah. So that's the first step.
And of course, the more you can automate the testing, the better, because you don't rely on the human eye then.
Exactly, and that's so, a really good takeaway from your talk. Yeah.
So a lot of the vulnerabilities you look at, you're basically looking at user communication to the driver, and so you don't really need some hardware device doing something strange, but you're talking more to the user side of in communication.
That's almost entirely correct, except in places that the drivers actually require a hardware counterpart. In this case, you need either to emulate it or to use a PC to a PC or a laptop to a laptop means of communications, because you actually need the device. In the worst case, you can patch some of the driver code, but it's a lot more difficult and it's more time consuming.
Yeah, but it's a great question, and actually it's part of the things that we thought of that perhaps we might take on, and next research is perhaps maybe find a way to also in some way automate, although it would be very difficult, these stubs and patches to the driver.
Yeah, I can imagine.
Yeah, I'm saying good luck.
Good luck, have fun.
But you mentioned, I think you quickly mentioned in the Venno talk some horror stories. Did I understand correctly that there was one driver we had read-write against any memory?
Yeah, but that's a signed driver, and actually I hope that most EDRs and AVs understand when they see this driver. Well, it's a signed driver made by some company that allows you to read and write memory directly into the kernel, and it's signed. So if you're an adversary and you have an admin access to the machine, which is the required thing to load the driver. Even if it's a signed driver, then you can use it and you have kernel mode control and you can do whatever you want on the machine.
So one final question before we let you go and enjoy the rest of the conference here. What have the responses been when you've reported the bugs to the vendors?
Well, that's funny. Every vendor has its own like idea and concept how to treat those bugs. Yeah. For instance, some vendors took it very seriously and tried to patch it as quick as possible. But as we said, the development cycles are very long, and sometimes it's hard to compile the code again, so it takes time. In some cases, they want us to test the patches out, which also took some time. And sometimes they just fixed it, and on one occasion they said, we don't care.
Do you have any, like, maybe names of companies, or at least what kind of different peripherals the drivers are intended for?
Mostly how, like, if you speak about hardware-related drivers, so PCI cards mostly, so every vendor that is involved in that area probably has a vulnerable driver, Windows drivers, of course, processor drivers, let it be Intel or AMD or GPUs ones like NVIDIA as well. Yeah, very the good places to look for bugs.
Cool.
So now enable stupid mode here. So we got PC drivers, and you mentioned processor drivers as well. The processor drivers, what do they do? Do they install some microcode into the processor, or what are the processor drivers doing?
Mostly things that are concern the processor. They're not just, sometimes vendors, I don't want to blame any vendors, they use drivers to channel data outside. So like, how do you call it? There is a name for it in Windows, I just forgot. To send just data home to collect it, because now data is king and everyone is collecting huge abundance in data, and also for monitoring statistics and so on.
Also, there are usually multiple stacks of the drivers.
Yeah. So not all of those would be obvious to when normal people think about drivers. Is there any other sort of driver you have looked at, like normal people who haven't looked into the Windows drivers, things I wouldn't expect to be drivers or something?
Yeah, because if you want to hide your things, put it in a driver, and it automatically limits the amount of people that will look at it. There can be very simple things, but you put it in a driver and people think, oh, it's so complicated. But it's really not the case. There are complicated drivers, but not all of them.
Yeah, well, there's a barrier of entry, and things like what you have done is like trying to remove that barrier.
Yeah, but we believe that now it's easier than before, because there is great documentation nowadays, not official ones, because on Windows everything is closed source and you do not have symbols and so on. But it's a lot easier, I think, now than 10 years ago to find bugs in drivers.
So finally, you mentioned that you were going to publish some of this, the work you've done with and code and so on, and we were to follow you on Twitter. So you need to tell us which Twitter handles should we make sure we follow.
Oh, sure. So you want me to spell it or try saying it? Because it's
is this Mission Impossible?
For me, it will be more difficult, I assume.
Well, mine is Ocam Razor. It's OCAMRAZR.
Like the principle in machine learning of overfitting data. Yeah. And mine is Eran Shimoni, which is my name, EranShimony.
But you also can find it in our presentation.
Right. So thank you very much for taking the time to talk to us, and please enjoy the rest of the conference.
Thank you very much.
Thank you very much.
It was a blast.
And I can just say I will definitely watch your talk afterwards, because when I was looking through it, your talk was one of those I really wanted to look at.
So just out of curiosity, which part drove you most?
like just like how to fuss drivers, just general, like that's. So I worked a little bit with embedded developers and a little bit with driver developers, and I mean it's complicated enough to debug normal software and fuss normal software, and typically the approach would be, well, we'll build a test harness where we do the fuzzing and we fuss it in user land, and we don't do the drivers, and we just pick the C code and build a test harness which can test it completely independently of the hardware stuff. But I think for a lot, like when you move it into the driver stuff, then from that point on it becomes like you have disproven, but it becomes much harder for, let's say, normal people or people who haven't invested in how to do this. That's much harder. So basically, in my perspective, the code base is typically well tested until it's down in the driver. But so the things like the parsers and things, those you can easily extract and test when.
I believe that the same errors that you have on user mode fuzzing or like C vulnerabilities are completely the same. Just the implications are different.
Yeah.
And also there are of course some kernel specifics that change between Windows and Linux and Mac OS and so on. But every C bug just causes a crash in the kernel, mostly crashes.
And then I've always been like very impressed with people who do low-level either reverse engineering or exploitation of things, because I can say every single step is easy and trivial, and I can imagine that I can do that. That can be so hard. But actually building the entire chain from building a test harness, making a proof of concept, and doing all those things, and just keeping at it when the testing conditions isn't perfect. It's much easier when you're like, I just test in user land and I make making the job easier, but like you're doing it black box and just moving past all the barriers. That's one thing I think is very impressive, and I'm so impressed with people who like make exploits in weird environments or jump across all different hurdles of anti-exploitation things, like doing everything like, I can do that, I can probably do all of that, but actually doing the chain and solving all the problems necessary to do that, that's something I find extremely impressive, and I'm kind of too lazy personality to do that.
We are lazy too, trust us.
But you're lazy in a good way then.
Yeah, so thank you again.
Thank you very much. It was a very nice interview.
Recording video, perfect. Yes, welcome to the SECT live stream. Is it live? Is it semi-live?
Sort of semi-live.
I'm here with Ricky Bokfors. I'm today with Leo and Tom that just came off stage. We're talking about threat hunting, right? Threat intelligence. And it was a really interesting, inspiring talk. You can't go into any details, of course, because, for reasons. But we just agreed upon that we will actually be possible to talk a little more generic about threat intelligence and threat hunting, right?
Yeah.
So happy to have you here.
Yeah. Let me kick off with the first question here. You talked a lot about how you used threat intelligence to enhance your threat hunting techniques. Do you think that is something that more people should use in terms of when they go threat hunting?
Definitely. Yeah. I think it's we'll do it both. Like I'll start, you go second. Ladies first. Okay, so I think if you can do it, if you have the resources, because of course it's more costly, you should do it, because first it will help you to be more specific, and also you combine like other data into the hunting itself, so you're more accurate on the finding, and you can actually find even more. So I think if you can do it, go ahead.
And one thing important to mention that we also talked about, it is not a matter of or a simple hunting, I guess, or intelligent-driven hunting. The best method is the combination of both. Use both the simple IOCs and also the enrichment that you can do from threat intelligence. And this is the best way.
Because one thing that struck my mind is that there are, it's a chance that you might go down the wrong rabbit hole if you assume that a certain threat actor is responsible. In the case, and we won't go into that, but you had indications that a certain type of threat actor was responsible, and that led you to some discoveries. But the flip side of that is there's a big chance that if you assume something, you might look for corroborating evidence that will support your theories. So how do you avoid getting into this sort of information bias? Yeah.
So this is a very interesting question. And like you said, what we try to do when we do research is to always not to try to do the confirmation bias, and always to keep like an open mind, and always to say like if we find something doesn't, even if we like find few evidence that it is some threat actor, we never say 100% it is that threat actor. We always leave like I guess a window open, because I mean, there has been instances in the past that like some Russian APT disguised as an Iranian APT.
Yeah.
It also happens. So of course, if we find like several evidence it is threat actor, we like say like maybe with a high certainty it is Kim Sukh or it is APT 37 or something like that, but like never like it's definitely no. It always like keep like a window. Yeah, exactly.
Yeah. I think that's a good plan.
Yeah, because I mean, in the previous talks, we also see that I mean, as an attacker, you leave stuff,
false flags.
Yeah, that's the threat incident responders. They will find some Monero miner, and then that was Monero miner. Good, case closed. Move on to the next one, right?
Yeah. Also, you can have sometimes different attackers in the same environment, so you have to distinguish between different clusters.
Exactly.
So it's also very important.
We're not here to talk about me, but
but let's do it.
I was on one case where we had indications that a customer was attacked by a certain type of attacker. But what we saw was that there was, when we did a thorough investigation, was that they had been attacked way before that, and then once they were done, they basically sold the access to some script kiddie who trashed a lot of evidence just by using all kinds of script kiddie tools, and that way, you know, if we'd been sloppy, we would have just found the obvious, but once we dug deeper, we saw that there was evidence of another threat actor being there previous, and possibly, you know, giving away this access to trash evidence. Is that something that you've seen when you've worked with clients?
It's actually funny that you ask.
Because even
we just published about a month ago a research that we found 3 different Chinese APT group on one environment. And again, as you said, like there is a group that attacked like a few years before, and another group, and then another group. So again, we had to like distinguish the different clusters and work on it. But yeah, it's something that we keep seeing on different customers. If it's like an interesting customer, so yeah, a lot of people would want to attack them. So
what is interesting about that story, that at the first we only discovered, I guess, one threat actor, and we thought, okay, this is the threat actor. But we kept like investigating, digging around, and some stuff didn't make sense. Like this one didn't look like this actor; it looked like different activity. And then on those machines, that looked like something entirely different. So after we investigated it, we said, okay, there are some multiple threat actors inside the environment.
And that's something that you can't collect into a tool, right? You need the experience, and that's feeling something isn't right. There's some other things going on here, right?
That's why you need that threat intelligence aspect of it, because IR they can get you a lot of like evidences and artifacts and really cool things, but you need to have like these other aspect of threat intelligence to understand what you're looking at.
I mean, attribution is usually a really tough challenge, right?
Yeah.
Especially if there's multiple people inside there, or been over the time of history. Would you say that there is a good way to work with like forecasting? I mean, the threat intelligence, using threat intelligence as your forecasting tool, that there will be problems in the future, or how could you use threat intelligence to forecast what's happening?
I guess instead of like forecasting that will be problems, you can try to forecast, I guess, who is interested in attacking you. If you like see, if you work in aerospace, or you try to see like which kind of APTs like usually attack your kind of the Earth, your space of the Earth, and your kind of sector and industry, you can try to say, okay, mostly like maybe it's mostly Iranians, Russians APT, maybe it's usually stuff like that. So we can, I guess, do most of your research on this kind of APT to be prepared.
Cool. One thing that you talked about was how to start out, and one of the advice was start small. Start with a limited number of sources when you start doing threat intelligence. But what else could you say is important when you want to start using threat intelligence in an actionable way?
I think one thing is always to like doubt yourself. Maybe you are in the wrong path, and always keep like returning to the beginning and see if that fits what you are doing. Also to always try to improve yourself and tweak. If it's hunting query that you do, try to tweak them and to make them more precise. And then once you start small and you feel like confident with what you have, you can go a bit bigger and then see maybe other things. But again, you need to go back to the beginning, make sure you're still on the right path, so you don't go to the rabbit hole. And that's it. I think it's like, as Asaf mentioned in the presentation, it's not a linear path. You sometimes need to go back and check yourself.
Cool. So strict methodology is the key.
I think, you can say strict, but sometimes you need to change it because, like, according to what you do.
Yeah.
Of course, like, we started with the basic one, and then after we did the Kimsuki research, we, of course, changed it a bit and make it more suitable to what we do. But yeah, if you have, like, a list of things that's like, helpful for you, then, like, go over them. It's helpful in the investigation.
Cool.
Makes sense.
Well, we won't be keeping you from enjoying the rest of the conference. Thank you very much. It was a very interesting talk, and thank you for taking the time to talk to us.
Yeah, you and Tom, thank you for having us. Have a nice day, and have a nice stay here in Stockholm.
Yeah.
Thank you very much. Thank you so much. Och sen kör vi jingle. Yes, welcome to this small pre-lightning talk with Erik Hjelmvik that's soon will be entering the stage here at SecT 2021 here at the SecT podcast and transmission. Precis. Cool.
Thank you very much.
That's perfect. So we just heard that you will be up talking about something that you spent the winter around.
Oh yes, I spent way too much time reverse engineering the backdoor in the SolarWinds Orion product. I did it just to build a decoder for the DNS traffic, but the talk is actually not about my decoder. It's about a few other things I discovered in the code.
Oh, cool. That's cool. So really. Trying to trick us into watching your talk, I guess.
I think I will be watching it anyway.
Anyway.
But yeah, it's always interesting to hear what you have to say. But tell us about the messages that were sent out using DNS queries. Basically what information could you extract from that once you knew how to decode it?
There were actually only 2 pieces of information that was sent from these victims, or from the initial victims who were running the SolarWinds Orion platform. And the first thing that they would said was their internal Active Directory domain name. Yeah. So they would leak the domain name. Sometimes it was too long, so you had to actually split it into 2 or 3 DNS packets. After that, it would send the installed antivirus or EDR products. Actually, they only had a list of a few products, and if your product was on the list, it would sort of said that. And that's all the information the attackers got. So out of that, knowing the Active Directory domain and installed products, they sort of handpicked 1% of those to do further investigation or further attacks.
Exploitation, yeah.
Yeah, the other ones, they just disabled the backdoor, which means that for most victims, they just sent like 3 or 4 packets over DNS over like maybe 4 days. So 1 packet per day. And who would discover that?
That will go totally under the radar, right?
Yeah. And that's sort of what the talk is about, how they managed to stay under the radar for so long.
What's the impact that you've seen that when you're checking this message? In magnitude, how many infections?
When it was active, they got like more than 1,000 new victim organizations per month. I only see part of the data. I only see what people have gathered in passive DNS traffic. I would guess it's probably much more than that, but at least 1,000 victims per month is what they got, and they handpicked, probably less than 1% of those to actually do something about. The other ones they just shut down.
Cool. What got you into analyzing this malware then?
First of all, when this was published by FireEye, I realized that the update was actually still available from SolarWinds. So I downloaded it, and I discovered, hey, this is C# code or .NET. I'm a .NET developer, so I was like, yeah, let's have a peek in what is lying there. So I spent some time just looking around. It's like, yeah, okay, I get the general, like what they're trying to do. Yeah. And then, but I was like, yeah, but someone will publish a good decoder for this. Then after a while, I realized that, yeah, people publish decoders, but FireEye didn't do a decoder. Microsoft didn't do a decoder. It was a guy in China who did a Python script that would decode this. So it's like, yeah, but I can understand the pain trying to reverse encoding of .NET functions, but do it in Python and make sure that all your output will be the exact same things as a .NET function. So for me as a .NET coder, it's like, this is super simple for me. I just do the exact operations they do, but in the other direction, and I'll decode that. So that's why I felt, this is something we need.
Yeah. Because the decoding was it was not decryption, it was just decoding.
Exactly. It was like, not base 64, but base 32 with a custom alphabet. Just that I guess they used it to make sure that the output, the data they want to send is compatible with DNS. So that they just take the data and format it into a fake subdomain and to send it as a DNS query.
So how did because you said that you used your script to dive into this and analyze or notify the search of the different countries? How did they respond?
I have got so I provided this script to search organizations and in some collaborative groups where people work together to help make things more secure, and I've got really good support for that. People are thanking me for providing them with the tool. But my tool was only part of that. A big part was all these people who actually collected the DNS data, because my tool was useless unless you had a lot of DNS traffic. And I was super impressed of how many people actually helped out and gather DNS traffic, go into these specific domains so that victims could be identified and could be notified by the search organizations.
Definitely a community effort then.
Oh yes, indeed.
Perfect. Let's not keep you off the stage because you will be the first lightning talk here really soon now.
Yeah.
Great having a chat with you.
Nice to have a chat with you, Eric. It's a pleasure to have you over here.
Yeah, it's always nice to be here. Thank you.
Thank you so much. Just stick it when
standing in front of a TV somewhere. And we're going to continue with one more talk before lunch. So I'm just going to hand the stage over to Abram Arngren. Welcome.
Thank you. Can you all hear me? Is this working? Yes? Cool. So I apologize in advance because this is a very practical talk. Normally we do like a 4-hour workshop with this kind of content. So I've tried to compress it down. So if somebody wants access to the apps that I'm going to demo, and there's like longer slides and a longer recording, like it's more relaxed. If you see this is too fast, you can go to 0x0DELAYED.com free, and that's all. And there's also the vulnerable application that I demoed yesterday on the Lightning talk is also there for free available. So just to mention that. So I'm the CEO of 0x0DELAYED. We deliver training at Black Hat USA and so on. We do stuff with Cure 53, if you are familiar with them. Yeah, and I'm one of the project leaders for OWASP OWTF. So if you type owtf.org, that takes you to the OWASP project, which is about web security. So some of the apps that I'm going to talk about today, especially Smart Sheriff, which was mandated in the entire country of South Korea. There's a couple of public pen test reports, so this is a very good way to learn about security. So just for free, by reading these first 2 pen test reports, you can pretty much see like a bunch of things that you should never do in a mobile application. So yeah, I'll talk more about that later, and there's a bunch of other mobile pen test reports available for free. So we will start with XSS, and then mobile apps with local servers, what can go wrong with deep links, some interesting scenario that we found in a pen test with a deep link SQL injection and code execution, and then some tales of crypto fail and some API pwnage and so on. So let's get started, right? So XSS, web views and data exfiltration. Let's start with Android. So basically, on a mobile application, a web view is kind of a small browser. And of course, this can have HTML, JavaScript, and so on. So what is the potential, right? So we can have HTML injection, which in a mobile device can still be interesting because a mobile device, a mobile application is typically not going to show the URL to the user. So with only HTML injection, if you can craft a believable login page that sends credentials to an attacker, you can still do some pretty good damage there, right? Then XSS gets more interesting, and the scenario that I'm going to talk about is data exfiltration of local files using XSS, right? And then in some scenarios, you could even do cross-site request forgery as well, but that is kind of more rare. So we found this vulnerability in many mobile applications, but for the purposes of demonstrating it in a demo, without blaming the guilty, we modified an open source project that is called AndroGoat. So the official version will not work for this, but we modified it as part of the workshop where, using the modified version, this attack works, right? So basically, first we have to create some files on the application that we are going to steal later, right? So we go to insecurity test storage. This will make more sense in the demo. Share preferences, right? So we create like some, we save some data on the preferences, like my secret user, my secret password. In a SQLite database, the same thing. And then we can go to XSS, and we can start like trying some stuff, right? So we can try, for example, H1 hello. And you see that hello is kind of bigger, so that's kind of exciting. It means that there's probably HTML injection there. Then we can try some XSS payloads, right? Image source X, honor alert 1, script alert 1, and so on. So this demonstrates that we have XSS. And now the next question is, well, what is the context in which this XSS is running, right? So we know that with alert location. So in this case, we have, in the pop-up, we can see that it says file, right? So the URL is a file URL. So this means that there is no same origin policy. So we should be able to read local files if the web view is incorrectly configured or configured with weaker security settings, right? So in this modified version, there's two possible attacks. One is on internal storage, which is the data directory, so other applications cannot read this. And then the other one is on the SD card, right? So the SD card is interesting because it's kind of the Wild West of Android. So any application can read and write there as well. So you could have a malicious application on the phone that inserts something on the HTML from the SD card, and then when the victim application loads this, then you get XSS. So this would be another scenario, right? So first we have to find the paths of the files that we want to steal, right? So we have users.xml, and we have AGOT, which is the database. So the payloads look like this, right? So we send an XML HTTP request for the XML file, and then we alert it, right? So if the alert shows the contents of the file, this means we can also send this file to an attacker-controlled website, so we can steal local files, and we have this data exfiltration with XSS. And the same thing with the SQLite database, right? My throat is not very good today. So you can see there we have the alert of the user credentials, the password, and so on, and then the same with the SQLite database, right? So in the SD card, I already explained this. And then you can also like read files from the phone, right? So as long as the application can read the files, has permissions to read the files, you can read files like, for example, the phone configuration or even files from other applications, as long as the permissions of the file allow you to read this, right? So this is how that would look. The device here is a Xiaomi device, so this is the configuration from the phone, and then the SQLite database is to the right, right? So methodology-wise, you're trying to answer these questions like alert 1, we have XSS, alert location, is it a file URL? And then try to read the local files, but we need to know the location for this, right? So in Android, you need to have certain insecure settings in modern versions of Android, right? So before, this used to be like the default, but this was only up to Android 4. And now the developer kind of has to shoot himself in the foot to do this, right? So you need to have JavaScript enabled, and now universal access from file URLs, and so on, right? So, and also you need a file URL. So let's show this in a demo. So we are sending here the payload, and you can see that we can see the credentials for the user in the alert, right? So we can read an XML file. This is the SQLite database that we can also read. And now we will try the other files as well, right? So basically, you can just copy the payloads from a URL and then just try that, right? So now it's reading a file from Drowser. This is the file from the phone, right? So the Xiaomi device, and then this is from Drowser, so another application on the phone, which is loading a library that other applications can read. So yeah, so that's the demo. So now let's look at iOS, because of course this is also possible in iOS, and actually iOS had worse default than Android's up to iOS 13, right, which is fairly recent. So for this, we will demonstrate this using Dumb Vulnerable Insecure App version 2. So it has some web view issues exercise, and then we can try the same thing, like try hello with H1, and so on, right? So we are trying to answer the same questions. Do we get the alert 1? What is the URL? So in this case, we have an Apple web data URL, which is equivalent to a file URL, so we can also read local files like cellular usage and so on from the phone. So methodology-wise, we're trying to answer the same questions. Do we have the alert 1? Do we have the alert location? Can we read local files by knowing the path, and so on, right? So this is the vulnerable code, right? So it's loading an HTML string. This is Swift code, so which is kind of weird because normally you would expect the double quote to be concatenated, you know, like to be like you would expect like a second double quote to break the string, but in Swift you don't have to do that. You like do like this backslash, and then you have the name in parentheses, and this is concatenating the name input into the string. And then the other component that we have here is the URL is null, right? So there's an empty URL, so this means by default the web view is going to load this with kind of maximal permissions without same origin policy and so on, so we can read local files, right? So that is the problem. And this is the default for UI web views. So web views, UI web views by default have WebKit allow universal access from file URLs, and WebKit allow file access from file URLs. These are turned on by default, and you cannot even disable JavaScript. So these web views are vulnerable by default to this kind of attack. But I think now in iOS 14, like Apple started giving developers warnings about this. So you need to use the WK web view if you are a mobile developer, and then you should be much better by default, right? But you can also shoot yourself in the foot by enabling these insecure settings. So yeah, it's about concatenating user input into the strings. So let's do a demo for this one. So we are trying first the alert one, right? So we get the alert one, so this confirms we have XSS. Now we have to do the alert location to figure out what is the security context in which this is being executed, this XSS. So this tells us that it's an Apple Web Data URL, so we should get excited because this means there's potential for data exfiltration. And now we will try to read some local files as well. So this is reading the data usage, and there's other known paths in iOS for certain files, right? So yeah, so you can see that you can read SQLite databases and so on. So as long as you know the path on the phone for the file, you are good to go, right? So yeah. So that's the demo. So now let's see some attacks on using the SD card on Android, right? So the SD card is dangerous location in Android for several reasons. One is any application can write there or read from there. So if you save anything sensitive on the SD card, a malicious application could read it. And then another problem is even a regular thief without elite skills can take the SD card out without even knowing the unlock pattern, plug this SD card into a computer and read everything in there, right? So by default, there's no encryption. You can take it out without even knowing the unlock pattern and so on. So yeah, kind of a memory problem. And yeah, let's see some scenario of saving sensitive stuff in the SD card, right? So this was a whistleblower application meant to be used in countries where they have kind of this oppressive kind of government and trying to let citizens report human rights violations. Unfortunately, this application was saving the human rights violation reports that people were entering in the SD card. So this could get somebody killed in a country like that, right? So you have police stop you, then they get the SD card out, they plug it into a computer, they see that you are reporting these human rights violations, and maybe they kill you, they send you to prison or whatever, right? So this could end up pretty badly, and this was all the data from the human rights violation report. Another scenario, what happens if you read data from the SD card, right? So this was an application loading text files from the SD card. So in this case, we have persistent XSS with data exfiltration, right? So we have a chapter text file being loaded from the SD card, then this is stored in a page data variable, and then the page data variable is concatenated into a string in HTML. So we have HTML injection and XSS. And then now for this, it's very useful to use Hack Vector, which is now also a Burp plugin. So you can use eval from charcode if you have trouble with some characters that are breaking the application or whatever. And this kind of makes it a little bit easier sometimes, right? So this turns the payload that is retrieving the file into eval, string from charcode, and so on, right? So you get rid of the single quotes, double quotes, and it's more likely to work. So yeah, this was the persistent XSS with data exfiltration. And yeah, so now let's see spoofing attacks, right? So in this case, you can use, for example, one URL to a user, but then when the user clicks on this, they really go to another URL, right? So a trick for this is to use left to right and right to left characters. So this has been used in the wild, and it can be an interesting attack vector, especially when the application linkifies automatically, right? So you can, for example, send some right to left characters, and then you put like mock.evil.org, and then when the victim really sees grow.live.com, but then when they click on it, they go to mock.evil.org, right? So they go to the reverse, right? So this can be an interesting vector. And then something that you would normally not think about is like a mobile application can sometimes have a local server, right? So it's kind of crazy, but possible, right? And then you have to worry about authentication, authorization, and so on. So this was a Cordova iOS application that was running a local server. So it had path traversal without authorization, so you could, by knowing the port, like a malicious application on the same phone could browse fast, right? So you could do this // of sequence of this, and then it's the password and so on. So you could read like local files and so on by using this local server, right? So this is a vector that normally you would not think about in mobile security, right? So you could like dump all the files like this, just in a shell one-liner and so on, right? So question for the audience: does cross-site request forgery exist in mobile apps? What do you think? Any takers? Cross-site request forgery exists in mobile apps? Yes, no? Maybe show up of hands, yes? Okay, so some people say yes, no. Okay, so yes, so cross-site request forgery exists in mobile apps, and especially with deep links, right? So this has it's a popular vector for like bug bounty stuff and so on. So I'm going to go a little bit fast for this because I want to cover other stuff later. But the slides are meant for like people trying to follow the exercises with the slides, right? But basically, in Android, you're going to have some deep link activity. This can be browsable or not. If it's browsable, then it's more exciting because it can be attacked from the browser also. If it's not browsable, then only a malicious application installed on the same device will be able to attack it. So we have one possibility is that the deep link activity has an intent filter, and then the intent filter defines the structure of the deep link. This is not necessary, but it's often like the way in which this is implemented, right? So I'll show other examples afterwards. So in this case, we have an Android scheme of some app, host of getcreds, and path prefix of user. So this is kind of the structure of the deep link that the application expects, right? So for this, I'm going to show a case study of cross-site request forgery using deep links on Periscope. So we have like the vulnerable version as part of the workshop that I mentioned before. So basically, first you need to create a Periscope account, and then we look at the Android manifest. With APK tool, you can decompile it. And then we can see that there's some browsable activities, and we can see the activity that we're interested in has a scheme of PSCP and a host of user. So what can we do with that, right? So we can send an ADB command, for example, sending Android intent action view, and then with the D, we pass like the intent data of PSCP user and then the ID of some user, right? And you can do this as well with Drowser and from a browser, so I'll show all methods. Also, with Drowser, there's a scanner, so you can scan for browsable activities, but this scanner is not super reliable, so it's going to miss some combinations, right? So you shouldn't rely on it. This is the output from Drowser. And then the actual cross-site request forgery vulnerability is that you can send a deep link, that is going to automatically follow any user that you send to the victim without any confirmation from the user, right? So this is the actual vulnerability. So before we were just opening the profile, but when we add the /follow, the issue was you could like make the victim follow any user you want, right? So there's several ways to test this. One is with Deep Link Tester, which is an application on Google Play, and then you can send the, like type any deep link and then click on go to URI, and then you can see that the user starts being followed. And the same with ADB. So ADB is what I normally prefer in pentest because every developer knows about ADB. So we can add the /follow there, and we can do the same with Drowser, right? So these are all the main ways, and also from a malicious website, right? So this is also available on this website. So you can also test it from there. And yeah, so if you just click on Periscope Cross Request Forgery demo, then it starts like following the user as well. So this is the HTML, and I'm just going to show the demo. So first is going with Deep Link Tester, and it's going to follow the user. So it goes to URI. You can see that it changed to following, and then you have like to unfollow and close the user so that it follows again, right? So now we're going to do it with ADB. So you just send the intent with ADB, right? So ADB shell and so on. And we add the /follow, and then when you open the device again, so here I was like missing some quote. So yeah. And then you can see that it changed to following, right? And then we can do the same thing with Drowser. So we first have to unfollow, we close the user, and then you just go to Drowser and add the /follow at the end. And then this changes to following as well, right? And then from a malicious website, you can just go to this link. It says it requires no authentication or anything, and then you just unfollow, and then open the browser, and just click in there. And because the activity is browsable, the deep link arrives there, right? So I'm just explaining how deep links work. And now we will show other examples, right? So yeah, we need to go deep, right? So we're going to see more deep link scenarios now. So now let's see some deep link attacks to make phone calls. So in this exercise, we will use the vulnerable insecure app, but this is also a problem that happens like in real applications, right? But this is just for demonstration purposes as part of the workshop. So first in iOS, you look for URL schemes. So in Android, we were looking at the Android manifest. In iOS, we look at the info plist, right? So this is kind of the equivalent. And then in this case, we have dump vulnerable insecure app and dump vulnerable insecure Swift. So these are the two URL schemes. If you have Xcode, you can look at this by looking at the project, info, and then scrolling down to URL types, and then you have URL schemes, right? So this is how that looks. And then we know how the deep link starts, but to know what the application does with this deep link, we have to look at the source code, right? So that's the easiest way. So that is going to be done in the app delegate. If the application is written in Swift, this will be appdelegate.swift. If it is written in Objective-C, it will be appdelegate. So it's looking for phone call number, and it's going to split this into an array called split URL, and then it's going to cast, if you're familiar with PHP, this would be the equivalent of explode, and if you're familiar with Python, this would be the equivalent of split. So basically, it's taking a string, looks for phone call number, and then it's going to explode this into chunks, right? So the chunk 0 is going to be the deep link, and chunk 1 is going to be the phone number, right? So then it casts the phone number to an integer, and if this works, it assumes it's a valid phone number, and it tries to make the call, right? So yeah, if you look at Xcode, this is how the code looks there. And Based on this, we know now the structure of the deep link, and we can demonstrate from a malicious web page, right? That the user clicks like win an iPad now, and then it makes a premium phone call. So this is an interesting attack vector on mobile applications to monetize the attack, because by making the user ring a premium phone number, you can make money basically as a criminal, right? So this is these are the deep links. It's basically just a web page with links to the deep links, and then the only thing Safari tells you is open this in the vulnerable insecure version 2, and then you just tap on open, but you don't really see the link, right? So here we're showing the link because this is just for demonstration purposes, but in a real attack this would say win an iPad now or something like that, right? So yeah, so let's do the demo for this one, so that you see it working. So basically, you just click on the link, and it's going to make the premium phone call, right? So you tap on open, and then it says success, and it's just simulating that it's making the phone call, right? And the same with the other URL handler, because there's two, right? So it does the same thing. Okay, so with that, now that we know what deep links are about, let's see some scenarios from the field. So one possibility is that you have an application that is a browser application, right? So you have a URL, and then this URL has to be opened by the browser. Now, if you have a malicious application on the phone, what you can do is to save something on the SD card and then make the browser go to this location on the SD card and then try to read local files, right? So this is the scenario, right? So this is, in this case, the deep link works in a slightly different way. So in this case, we don't have an intent filter that tells us the structure of the deep link. This is actually done in the local files, right? So this was all the data exfiltration, retrieving all the databases from the application and then sending them to an attacker, right? So we have a deep link and then XSS with data exfiltration, right? So we are combining the concepts that I explained before. Yeah, and then now let's look at another scenario. So this is a browser application that goes to an attacker website that attacks the deep links, right? So this is a slightly different approach. So in this case, this was the Onion browser, one of the early versions in iOS. And what we could do is, from an attacker-controlled website, we can call the deep link from the application and do Onion browser force quit. So if you showed an image like this, the browser would automatically close without any user interaction, right? So you can invoke functionality in the application by using deep links, right? So this is also an interesting vector. Now, another very cool attack is a deep link that results in SQL injection and then results in code execution, right? So this was a very cool vulnerability. So this happened in a CRM application with Google Authentication. So when the user tries to use the app, you get prompted to log in with Google. So there's like a pop-up, and then the user logs to Google, and then the credentials go back to the application using a deep link that sends the Google token, right? So that is the idea of the implementation, and this is the code. So we have, in the Android manifest, we have the login web view. It's browsable, so it can be attacked from the browser as well. And the scheme, we will call it a vulnerable app to protect the guilty. And then in the code, you can see that there's database db.execute SQL, update credentials, set call, and then there's a concatenation of the value, right? So we have SQL injection. And then the question is, how can we turn this into code execution? So it turns out in SQLite, when you use the SQL Cipher extension, then you can load extensions as well from SQL, right? So in this case, we can do select, load extension, and load a library that we know the location of on the phone to get the code execution firing, right? So there's two potential scenarios. One would be a malicious application, so we can simulate this by going to, for example, data, just trust me, and then we create a test.so file that has a lot of A's, and then we give it permissions with chmod 777, so any application on the phone can read this, And then we send the intent that exploits the SQL injection, loading the extension that we know the location of on the phone, right? So this was the error on logcat. So you can see it says SQL cipher DL open failed has bad elf magic. So it's trying to execute it, but it sees that it's not a valid binary. But this is enough proof to know that this is code execution, right? Because it's trying to run it. So yeah, this is remote code execution, so always exciting. And then also in supported versions of the application, this was also exploitable from a browser. Now, because you need to provide the library to load to turn it into code execution, this was a little bit tricky, right? So we need to take the user to an attacker control website, and then this website has to make the user download and then run it, right? So we need first one file that is just going to send the binary to the user. So we're basically doing test.so, and then it's just having a lot of haze. And then we need to load this in an iframe. So when the user visits this, it will automatically download. And then we wait like 5 seconds or something so that there's enough time for the binary to download. And then we exploit the SQL injection and get the code execution, right? So, and then we have the same error message in logcat, right? So this was pretty cool. Now let's talk about URL validation, right? So this was the logic of the application. So this was the Onion browser again. And in this case, it's trying to check that, because the problem is, if you have a .onion domain, then this domain is not following the normal TLS trust process, right? So it works in a different way. So it's trying to skip SSL errors, right, if it has .onion. But there's a problem here, because this is actually a very common problem when you do code audits, because it's just looking for .onion somewhere name, right? So yeah, this is going to ignore all the warnings, and we demonstrate the vulnerability like this, right? So we created a subdomain like www.paypal.com.onion, the domain we own, and then we make it point to a Google IP address. So when you visit that domain from a normal browser, you would get security warnings. But when you visit it from the Onion browser, there were no warnings, right? So this is a very common problem when you do code audits and the user does, the developer does something like if string in, if this string appears somewhere, instead of maybe they should be checking the start or the end, right? So very common problem. If you do code auditing, you really need to always look at this because there's always interesting bugs. So yeah, now XMPP is also an interesting protocol because lots of chat applications use this, right? If you man in the middle XMPP, you will notice that in the handshake at the beginning, it's possible to specify the mechanism, right? So you can specify, because you are the man in the middle, that the only mechanism available is plain, right? Because normally there's like a challenge response. So if you specify that the mechanism is plain, then the user credentials, if the application is dumb enough to trust this, will be sent in clear text, right? So they are provided base64 encoded, but you can basically base64 decode, and then you can read them, right? So this was also a nice attack. Also, attacking updaters, an interesting attack vector as well. So in this case, it was an application getting a JSON file from the server. So we can, because it was doing this over clear text HTTP, we can change the URL and specify a phone number as the place to get the update from. So then the application says new version available, and then you tap on update, and it makes the premium phone call, right? So these are interesting attack vectors in mobile when you can make the user click on something that makes a phone call. Things can get interesting, right? So it's an interesting vector to bear in mind. Another one was a third-party zip file retrieval. So in iOS, since iOS 9, there's this thing called app transport security that makes applications reject clear text HTTP traffic by default, but developers can add exceptions to this, right? So you should always look at the info plist for things like this, because if developers have an exception there, it's typically for a reason, well, that they need to make a clear text HTTP request to that URL for some reason. So in this case, it was an Amazon S3 domain, and this was the request looked something like this. So you can see it's a clear text HTTP retrieval of a zip file. So we have an arbitrary file override, because if we can provide any zip file we want, when the application unzips it, we can override any file we want on the application. So also a cool vector. Now let's talk a little bit about crypto. So a crypto messenger Android application. Can anybody see the vulnerability there? Any guesses? It's on the line that's highlighted. So the problem is the original file name, right? So whenever an application respects the original file name on the file system, things can get interesting, right? So in this case, we have an arbitrary file override on decryption, because a user sends an encrypted file to another, and then when you decrypt the file will be decrypted with the original file name provided by the user, and there's no sanitization here or anything. So you could encrypt a message with an original file name of .. something, and then when the user decrypts the file, you can do an arbitrary file override of whatever, right? Now PGP, this was a PHP email iOS application, so just going to skip this because, so basically at the bottom you can see there's a string concatenation on the message, right? So it says string escaped for JavaScript, but it was not escaped for JavaScript. So this is the actual vulnerability in the first line. So you can see self-message, string escaped for JavaScript, and there's a string concatenation in the JavaScript. So you could send an email to another user that had like a single quote, semicolon, and then the XSS payload. And then because the application is in the JavaScript, you can see it's doing first like the private key, the passphrase, and then the message, right? So by the point the XSS fires, the private key and the passphrase are already set in JavaScript variables. So when the XSS fires, we can just send the private key and the passphrase to an attacker-controlled website by the email. So this was also a very cool vulnerability. And then, yeah, the attacker can just receive this, right? So yeah, if you don't have private keys, they can't be stolen, right? So that's also interesting to bear in mind. So now let's talk a little bit an application very close to my heart that was mandated in the entire country of South Korea. So by law, every parent and child of this country was forced to install this application. This is true. And the idea was to keep the children safe, help parents be parents, and so on, right? So the pentest reports are public, so you can read more about it there. So the first time we tested them, everything was clear text HTTP, everything everywhere, right? So this was the first round, no SSL. What is SSL? No SSL anywhere, right? So all HTTP. And this is also quite common in Asian applications. And I don't know why, but it's what we found, right? So the second time, we noticed, okay, all URLs are HTTPS, so it seems like they fixed it, so that's nice. But then we looked at the validation of SSL. So this is what the validation looked like. On received SSL error, proceed. So if there's any SSL error, it's just going to proceed anyway. And then the second line, hostname verifier, that's all the code, return true. So all the hosts are good, and all the SSL errors are good, right? So basically, so we have from clear text HTTP and then to completely broken SSL, and then they were doing this crypto stuff with XOR. Now, there's nothing wrong with XOR. XOR can be very secure if you use a one-time path, for example. However, in a mobile application, if the mobile application has the hard-coded, the key of the encryption hard-coded in the binary, anybody can retrieve it, right, by reversing the binary. So the first problem was there was a hard-coded key, which could be retrieved. So we wrote this Python script with a hard-coded key to do the encryption and decryption and so on. And then this was the actual key. So they were like using this to encrypt the phone numbers in the HTTP request. And then in the second round, they added this AES layer, which was also using a hard-coded key like somewhere else on the phone, right? So this was the code, right? So by reversing the binary, you could get both the AES key and the XOR key. So this is completely like useless crypto, right? So because anybody can read the key. So at the end of the day, there's nothing wrong with AES, there's nothing wrong with XOR. But if the keys can be retrieved by the attacker, all the crypto is useless, right? So a key distribution problem. So the catastrophe summary is you have a phone number, then it is encrypted because anybody can retrieve the XOR key from the binary. Then the entire request is encrypted with AES, which is also a useless encryption layer because the AES key is also hard-coded in the binary. And then the request is sent to the server, but as we saw before, it's completely ignoring all SSL warnings. So this was the fail SSL. And then you get the response back from the server, right? So it was a complete disaster implementation. And yeah, let's talk a little bit about API attacks because then it would not, this talk would not be complete with this. So this is a path traversal. So typical, the developer tries to change ... to nothing. So this is wrong because you can provide ... like twice, and then ... turns into ... so you're back to the same place, right? So the attacker, instead of sending ... you still can get the traversal, right? So these are very... another case is a remote code execution in a file upload, Python using shell true, concatenating the command, and so on. So we could get like a reverse shell like this. So we have like to encode different parts of the request and so on. And then we got like a reverse shell back. And the server was already running as root, so no privilege escalation required. That's always nice. And yeah, so yeah, that's about that. And now let's talk about API leaks, right? So this is about the Smart Sheriff and stuff. So there was a sister, okay, no. So first, there's the Bully API. Let me see in 2 minutes if I can finish this. So in every classroom, there's always this child that is a bully, right? That he wants to mess or make the life of every other children in the class miserable. You've all probably know some person like this, right? So for this child, if he wants to make the life of some child miserable, the first thing to ask the API is, hey, I want to mess with this child, right? I know his phone number, and I really want to screw his life. What can you do? And then you ask the Smart Sheriff, this Korean application that I was talking about before. It asks the Smart Sheriff API. And then the Smart Sheriff API tells you, OK, for that phone number, this is the parent phone number. So now you can already do some damage there as a bully kid. Like you can call the parent for pranking purposes or whatever. But as a bully kid, you need the password as well of the parent, right? Because the parent phone number is cool, but to log in, you also need the parent password, right? So you could ask politely, right? In life, you should always ask questions. The only thing that can happen is maybe you don't get the answer you were hoping for, but when you ask questions, amazing things happen, right? And this is a very good example of this, right? So you ask the API, like, as the parent of this child. And Smart Sheriff, of course, gives you the password of the parent as well, encrypted with XOR, as we saw before, with the hard-coded key. So completely useless encryption layer. And with that, you could log in as the parent of any child in the classroom. And then you can say, well, this child cannot access any website, can never use the phone, cannot have any applications installed on the phone, right? Because that's what the application was for. And this is what the requests look like in practice. So you send the message request, and then you get back the parent mobile and the PIN, right? So because this application was mandated in the entire country of South Korea, you could try a lot of phone numbers at random and get all the passwords and so on. And then there's Smart Dream, which was a cousin application of this that was looking for harmful words used between children. So for example, if a child sends another child a message that contains the word sex, then it would count that as a harmful word, and then this message would be saved in the API server, right? So the problem was you could see the message of any child that had been flagged with some harmful word. And yeah, so this was all very bad. So I'm going to skip this one. So I'll show just the password one. So this is like trying random phone numbers in Korea, and then it tells you if it's the parent or the child. If it's the child, it tells you the parent phone number, and then from the parent phone number, you also get the password, and it was just trying the random phone numbers like this, right? So that's that, and then I'll show the Smart Sheriff. So this is the Smart Dream, which is the casino application. So it's telling you like all the messages and from what phone number it was, and then what the messages were. Now, this script was written by Fabian, and he replaced the Korean characters with random characters, so to protect the privacy of the people. But this is basically what it looked, right? So violence, assault, it's like you also get like the category, and then the phone number that sent the message, and the actual content of the message, right? So I think that's all the time I have. And yeah, so any questions? Or maybe I'll show another demo while we wait for the questions. So this like Smart Sheriff stuff was so bad that the pentest report was indexed by Google. So we reported also an XSS, and the XSS was indexed by Google, so you could like click on the link, and the XSS was still working. So it's like really funny, like you screw so bad that the pentest report is public, you report some XSS, the Google indexes your vulnerabilities, and you can like click on the Google result and get the XSS firing, right? So this whole like Korean application was like catastrophic. Okay, so sorry. So time for questions.
Well, first of all, thank you very much, Abraham. I think people are hungry, and there's no questions that came in. I don't know if we have any questions that we want to take in the audience with the microphone. Otherwise, I think people are starting to get hungry and want to go eat. And maybe they will grab you during lunch hour.
Sure, feel free.
All right. Then thank you, and we'll be back here. Then we get lunch quarter of an hour early, right? So we'll be back here at 1:15. Thank you.
Thank you. Just
All right, have a seat, 2 minutes, and then we're going to start the next talk. All right, so I think most people found a seat or found a TV somewhere. And I hope you enjoyed lunch. Was it good? A few yes? Ow. I liked it. Cool. So then we're going to just continue with the talks, and we're going to have Polikt talk about all our favorite chat app, right? Big welcome for Polikt.
Okay, so hello everybody, and thank you for having me. So now we are going to talk about the animated stickers feature in Telegram and the remote attack surface it exposes. This is going to be our agenda. So first, as always, a little introduction about who I am and what is the Lottie animation format. Then we'll switch to the Samsung R Lottie project and its integration in Telegram. Then we'll move to the actual technical part, which is my fuzzing efforts and the issues I have identified in Telegram. And last but not least, some closing remarks and conclusions. So before I begin, I just want to ask you if anybody in this room is part of this Telegram group. You can raise your hand. Okay, quite some of you. Okay. So since we are going to talk about Telegram vulnerabilities, remember that we are actually watching you. So I would suggest you to disable your internet connection during the talk and after. Of course, I'm joking. So let's dive into the introduction. So as I said, I'm Polikt. I'm a vulnerability researcher and exploit developer at Shielder. Currently, I'm also the research team director there. In my free time, I enjoy backpacking around the world. And you can ping me on Twitter in case you don't get the chance to ask a question to me. And please note that all opinions expressed in this talk are mine. So what is the Lottie animation format? Basically, it's an image format based on vector graphics created by Airbnb. And you can create a Lottie animation by directly translating Adobe After Effects. On the right part of the screen, you can actually see an example of a Lottie animation. This comes from a Galaxy Watch app by Samsung. And you can see here a small list of the vendors actually using Lottie animations. Most probably, the most important here for us is Signal, but remember that most of the vendors actually render animations coming from the local file system, so they are not remote images. So technically, what is Lottie animation? Basically, it's a JSON-based text. You can see here the 5 main attributes it needs. So first, there is the version identifier, then the frame rate, in-point, out-point, and last but not least, the layers attribute, which is actually the most interesting one because it contains the actual vector graphics animations and changes in the animation. So let's move to Samsung RLottie project and its integration in Telegram. So basically, the RLottie project is a C++ library for rendering Lottie animations, and it is more performant than the Airbnb's Swift or Java libraries. As I said, it's developed by Samsung and it's open source. You can surf its code on GitHub. But there is a twist, because they don't actually track security bugs coming from parsing untrusted images, remote untrusted images. This is, of course, a legit decision by them. But in case of Telegram, this creates a problem because they will need to track and fix all of the issues coming from parsing animated stickers in Telegram themselves. So let's have a look at the main APIs in RLottie and how we can use it to actually render an animation. So first, there is the import function, which is the load from file method, which will load the JSON from the file system. Then we can directly render a specific frame number in a surface buffer. So basically, we have everything we need in order to create our harness and start fuzzing this. So how is RLottie integrated in Telegram? Basically, first, the animated sticker is sent, and this is the general flow of an animated sticker and where it starts and where it ends its journey. It starts from being sent from a client, and note here that you don't actually need a real device in order to start a Telegram chat. You can just emulate a device. After it is sent, it is received by the victim, and depending on the client, the animated sticker is parsed and rendered either when you open the chat or just when the victim receives the sticker. So this makes the difference between a 0 or 1-click remote attack. Once the animated sticker is rendered, it actually, depending on the client, for example, we are going to see the Android code for Telegram, and in that case, the Java code will call the RLottie native library through the Java native interface. In the end, RLottie will decode and parse the animation as we have just seen in the quick start. So let's dive into the Telegram code for Android. As you can see, first, once the client receives an image in a chat, it checks the MIME type of the image. In this case, application/x tg sticker is the MIME type corresponding to the animated stickers. And you can see that in that case, it sets the image type to image type Lottie, since it's going to be animation and it's going to be rendered. Then it creates the RLottie drivable object, which will in turn call the actual RLottie API we have seen in the quick start and we can use in order to fuzz it. So as we have seen, basically, RLottie is reachable remotely, and it may make a difference between a 0 or 1-click attack, but it is actually C++ code reachable remotely, so it's a problem. Another thing to note is that by default, the Telegram official clients enable all the animations in the chat. So by default, you get any animated stickers you receive rendered on your phone by default. So let's move to my fuzzing efforts. I have a kind of North Star here, since also like Magnus mentioned this morning, I also try to do like the easiest way possible first, then maybe move on and get smarter. Here is the same, so I will try to fuzz it in the like easiest way for me possible, and then if I see that there is actually the possibility to be smarter and find some more issues, I will try that. You can see this meme represents basically this concept, and this comes from InfoSec. So what we can do, what is the easiest way in order to fuzz this, in order to fuzz Erlotti? As we have seen, it's an open source project, so you can basically instrument it and fuzz it how you want. Personally, I've started by using AFL++, but of course, you can use any fuzzer you prefer, so libfuzzer, ongfuzzer, or whatever you prefer. I think three are the main things to note here. The first is that the corpus, so the starting files from which mutate and create new potentially crashing test cases can be extracted from actual community-generated animated stickers, because when I tested this, the animated sticker feature was actually just released, so a lot of people already started generating animated stickers just to try it, and also because, as I mentioned, the animated stickers are actually smaller in size than GIFs and videos, so they are more easily shared in the chat. The second thing to note here is that the crashes actually started to appear after just some seconds, so either no one fuzzed this, or who fuzzed this didn't report the vulnerabilities to either Telegram or Samsung themselves. I think the latter. Third point about minimization, we are going to talk about this also later, is an endless brute force, because as we have seen, since the animated stickers are actually JSON-based text, a minimizer will just try to remove some bytes, but will most probably break the JSON syntax, so it's useless and it's just a brute force cycle. A thing to note here is that not only minimization is going to be a brute force, but also the root cause analysis will be hard, since you don't know actually which part of the animation is crashing the library. So for who has done already some fuzzing, you can recognize this view. This is actually the AFL WhatsApp view. You can see here, this comes actually from the very first fuzzing cycle I did. You can see the hardware specs below. And in this view, you can see that after just 13 days, it has found 1,500 crashes. Again, here, AFL is not that smart, because it can't differentiate between two crashes which are actually the same, but the animation is different because it might be a different code path. So after doing this, I wondered, okay, there are a lot of bugs here. Let's see how I can make this in a smarter way. So I can avoid brute forcing the minimization, or avoid spending so much CPU cycles in order to mutate a JSON and most probably create a bad JSON because it doesn't respect the JSON syntax. Google has created this technology called protocol buffers, which are basically C++ structures, but in a language agnostic way. So you have the message, which is almost the struct keyword, and then the name of the message. By using this technology, you can pretty much describe anything. In this case, you can see a simple example of a person with three attributes: the name, the identifier and the email. And by using protocol buffers, you can just encode and decode information by respecting this specification. Anyway, you can read more at the link below. So we know that Lottie has actually a specification. R-Lottie, the Samsung library, is a little bit different, so I created the grammar for this library in specific since I wanted to pawn Telegram. And as you can see in this preview, there are two custom messages, which are the layers attribute and the assets attribute. The other are pretty much basic ones. Writing the grammar for the R-Lottie protocol was pretty hard since it wasn't done before, so I couldn't start from something already done. I had to write it from scratch. And I had to decide between the protobuf version 2 or version 3. In the end, I chose version 2 because they allowed the optional statements. But it was hard in the end. So by writing a protobuf grammar, we can actually use a custom mutator in any fuzzer we want. In this case, Google has also created this libprotobuf mutator, which is a custom mutator which can actually mutate protocol protobufs. So in this case, I'm not going to use anymore the built-in libfuzzer mutator, but I will move to that. So how is the structured fuzzing flow like in a high view? Basically, by starting from the grammar, we can ask the mutator to mutate a randomly generated animated sticker, which will arrive at the harness because you must note that since protobufs are not actually JSONs, we need a way in order to translate this protobuf view into a JSON because our library actually parses JSONs. So in the harness, I wrote the code in order to do this translation, which will in turn go to libfuzzer and test that specific test case with the libfuzzer instrumentation and will collect the coverage in order to potentially mutate the new animated stickers in a different way in order to reach more coverage. So let's have a little comparison of the fuzzers I wrote. Of course, here it's just my experience. Your mileage may vary, since this was a really specific project which might not be compatible with other things. So I've divided basically my fuzzers into two types. The first is the standard coverage guided, so just instrumentation, then running with a simple starting corpus, and then structure aware, which is using the protobuf specification. Some things I already mentioned. So for example, the time to fuzz, it's way lower for coverage guided since you just have to run it and find the corpus. But I will point the attention to the bolded text, which are actually the most interesting ones. So in the structure aware, I needed to write more than 20 versions of the harness, which is the code responsible for taking in the protobuf defined animated sticker and translating it to JSON and then calling the right APIs in R-Lottie. While in coverage guided, I just needed to write it one time because it was always the same. The slowdown was also particularly bad. I think this is because I needed first to create an animated sticker from scratch, then translate it to JSON, and then test it against the potentially insecure R-Lottie APIs. Last but not least, the time to results is way longer since it actually needed to run for way more time. You can see here it's per 3. In order to find the same issues or more. Because as we can see in the next slide, I have actually found 2 additional issues by using structure-aware fuzzing. And I think this is because mostly, as we have seen in the earlier slide, most of the mutated JSONs were broken JSONs, so they were useless, and they wasted so many CPU cycles. Another thing to note here is the coverage limit, because in coverage guided fuzzing, it heavily depends on corpus. So for example, if you didn't have a specific animation in your corpus, it's really difficult for the fuzzer to create it from scratch, since it will first need to stick to the JSON specification and then also stick to the Lottie specification, and it's pretty impossible to do that. While in structure-aware, there is theoretically no coverage limit, since it should be 100%, but in this case, RLottie also included some APIs which were not used in the actual Telegram code, so you couldn't reach 100% because they were not used. Last point in this comparison is about the test case minimization comparison. So as we have said, both are slow in coverage-guided fuzzing, since the animated sticker is pretty much a mess. Imagine like 3 kilobytes of JSON, one-line JSON. While in structure-aware, it is scriptable because it already knows what is the specification it needs to stick to. And it's also, the comparison is also direct because it doesn't create meaningless animations part in the animated sticker. So let's move to the findings, then live demo and the exploit limitations. So as I mentioned earlier, I have identified 13 issues in total. This is the full list. We are going to have a look into the heap out of bounds right. But you can find all of the details on our website, shielder.it/advisories. Also note here that usually in this context, null pointer dereferences are useless. But in this specific Telegram chat context, it was a problem, since it will make the chat crash every time you open it. So you would not be able to recover the messages before the crashing animated sticker. So the non-tech savvy people will not be able to recover the previous messages. They will need to either open the Telegram database and remove the animated sticker, or in some way instrument with Frida the phone. So let's have a look at the heap out of bounds right. As you can see here, there is a little preview snippet of the address sanitizer report. As you can see, there is also the stack trace below, and we can see that it actually starts in the render seeing API, which, as we have seen in the quick start, it is used to render a specific frame number. You can see also that address sanitizer reports it as a heap buffer overflow, so it's a heap-based buffer overflow with a write of size 4 bytes. So this slide is a bit dense, so I will try to point with my mouse here the correct variable. So basically our input arrives at the stop, vgradient stops, and it will influence the start and cur variables. So in turn, it will also influence the cur color. And you can see that cur color is an unsigned int 32, which is of size 4 bytes. We arrive at the while loop, and you must note that here they don't check that pos is actually less than size, which is the color table array length. So potentially here we are able to write out of the color table bounds, which is what happens here. So let's try to do a live demo of this vulnerability. Okay. Successful. I will just try to reconnect it because it disconnected. Okay, I guess we can see the video I have prepared. Okay, so basically you can see on the right part of the screen my test device. Here I'm just showing the Telegram developers that I'm actually using the default settings for my device and showing also my Telegram version. And you can see here that the autoplay is actually disabled. We can skip a little bit. Okay, here in the center part, you can see the ADB shell on the actual victim device, and we are going to grab the logs for the actual crash in the Telegram app. In the left part of the screen, you can see that I'm gzipping the animated sticker because in Telegram they are actually used gzipped and not as plain JSONs. Then I will just send to my victim account the animated sticker, and we will see what happens now. So now it's trying to create the secret chat with the victim. Note also that the victim doesn't have the contact, the attacker contact imported in Telegram. And you can see that the victim automatically joined the secret chat without any interaction. Now the attacker is trying to upload the animated sticker to the victim chat, and you can see that we can control the text on the victim chat. Now you can see that it actually crashed, and here is the address sanitizer crash. Thanks. Okay, let's go back. So let's have some exploit considerations and limits. As I said, this attack is only possible in secret chats. This is because in my tests, I couldn't send malicious animated stickers in clear text chats, which are the default in Telegram. I think this is because Telegram is doing some kind of filtering on the server side, but I couldn't verify this also because the server-side Telegram code is not open source. So as we have seen, weak default settings, so for example, the autoplay feature and the documented server APIs allow a large-scale attack from a single computer because you don't need to have actually even a real device in order to attack anyone. The heap out-of-bounds write is only exploitable probably on 32-bit platform since it's a 4-byte out-of-bounds write. And last but not least, ASLR is still a big problem here because I couldn't find any remote info leak in order to bypass or a memory probing oracle like, for example, Saelo did in iMessage. So let's have some closing remarks to end this presentation. So how did they patch these issues? Of course, they patched the RLOT library, but they also introduced this defense in depth measure. As you can see, anytime the Telegram client receives an animated sticker, it will test if the received animated sticker is actually part of a public sticker set. So you cannot create animated stickers from scratch and send them to somebody. So they need to be part of a sticker set. So potentially you could also attack the Telegram server responsible for creating sticker sets, but as I said, the server-side code is not open source, so I couldn't verify this. Another potentially unrelated patch or new setting they introduced is the filter new chats from non-contacts, which is not enabled by default, but if enabled, it will automatically archive new chats from non-contacts. So you will not be like vulnerable to clicking by error on a new secret chat created by the attacker. These are the patched releases. So as you can see, they are released almost 1 year ago, so you should all be patched now. And last but not least, an important dilemma, which is coming from quite some years, which is the competition between user experience and security. From my experience with this research, I've seen that Telegram strongly, for Telegram is very important the user experience and not the security, because as we have seen, they exposed a C++ library basically to the world. So you could actually exploit some victim by using these vulnerabilities. Thank you for listening to my talk. I will answer to any question you might have. Anyway, if you don't have any question now, I will be in the con, so you can catch up with me near here. Thank you.
It's a short talk, so we don't usually have time for questions, but I'm actually very curious. Did you find another tool, another app that you can use to keep fuzzing RLottie after the patches?
No, actually, after we sent 2 reports to Telegram because we fuzzed this for quite some months. After these defense in-depth measures, for example, the checking of the single sticker to be a part of a sticker set, after this patch, we stopped fuzzing because we would have to find an additional issue, which is a bypass for this patch, and then an issue in the RLottie library.
Yeah, because I figured there must be other apps that also use it, right? Not just Telegram.
Actually, the Samsung library for parsing Lottie animation, so RLottie, for what I know, is used by Telegram. Maybe some Galaxy Watch apps, but I didn't look into it.
So there's potentially a lot to find still.
Potentially, yes. But as I mentioned before, most of the Lottie vendors are actually using the Airbnb libraries, so Java and Swift library, which I didn't fuzz. They could have bugs, but I wanted to point the attention to the C++ code first.
Cool. Thank you. Thank you.
Thanks.
We're going to have a 15-minute break and then the next talk up. Thank you very much, Pollicht.
Thanks.
2-minute warning. Come in and sit down or find a TV and we'll start in 2 minutes. All right, to keep us on time, we're going to start the next talk. If you're not sitting down, sit down. If you're not seeing a TV, you can't hear me saying this. I'm just going to hand the stage over to Lucas Lundgren. Welcome.
Thank you. Thank you very much. All right, mic check. I hear myself and you hear me as well. That's great. All right, topic, sticks and stones, breaking bones. Before we start, I would like to say thank you. And thank you to SecT for hosting us during COVID and that you guys are here and kicking COVID in the ass. Thank you for staying safe. Thank you for taking care of friends and family around the world, wherever you are. And in January 8th, 1986, the mentor wrote in Frack magazine something that is should be more true now than ever, and that is, we exist without skin color, without nationality, without religious bias. And that was the Hacker Manifesto. And today I think it should be more true than anything. The topic today is going to be very close to home. For the last couple of years, we've been battling this virus that's been going on, and we lost some good people, sadly. The equipment mentioned here today is the equipment used to actually monitor the damage caused by COVID. But in difference to my other talks, where I usually just crash and burn on every security thing there is, I'm going to be a little nicer and see what we can do about it. So enjoy the presentation, guys. For those who don't already know me, my name is Lucas Lundgren. I turned 40 this year. Who knew? I didn't think I received 40, but yet here I am. I'm the father of 3. I got a dog, a COVID dog, of course, because we were bored. My COVID interests have been making custom keyboards lately, and as well as writing a book. Tried on some graffiti, not outside, but with pencils. I'm not ready to show that work yet. Professionally, I've been a speaker at DEF CON, RSA, SecT, Black Hat, and hold a pen testing position at NCC Group, IOActive, and a couple of few. Some of the notable clients I work with is Amazon, Microsoft, SAP, Apple. And my main job is pen testing. I do everything from web apps to whatever I can get my hands on. Some of you have also known me for my previous work on the MQTT, IoT security and the iSCSI stuff, which is out there. And I'm always scanning the internet. So I'm scanning for obscure protocols, hint like the one we're going to talk about today, and other things. I've also started to do some hardware hacking, and maybe something come up for SecT 2022 if it's relevant enough. I have to mention my current workplace, so blatant ad for my workplace. Awesome people there that I work with. They can stand me, which is perfect, I guess. These are my friends, my colleagues. Thank you guys for being there. We're going to talk about DCOM and PAX, and some people know or don't know what this is about. You can see the X-ray image, and that's a big hint. We will go through a little bit more in detail what this entitles. We'll go through the history, how it came to be, what it's used for, and how it looks today, as well as, sadly, the problems that we see, especially in security. There are some 80s acronyms that you need to be aware of. And when it comes to 80s and acronyms, they're a bit hasty for me to remember. So PAX is Picture Archiving and Communication System. DCOM is Digital Imaging and Communications in Medicine. We will get into more detail what those are in a bit, but you need to remember those because those are important. So, first version of the DCOM standard, 1984. This was developed in the early 1980s by American College of Radiology, also shortened as ACR, and National Electronic Manufacturers Association, NEMA. They were doing this because you need images, you need a way to store images, you need to have images and X-rays. And back in the days, the standard was actually depending on the brand. You might have seen in the movies where they hold up this X-ray image and they put it on this white, bright background. I think that is, I don't know if they still do it like this today, but that's what we're talking about. In 1992 and 1993, we saw a large-scale deployment. The US military started using PAX, as they named it, because it was born at the same time. And PAX is where you store all the images. Version 3 was also released. Note here that the name DCOM wasn't until 1993 where they introduced, ACR and NEMA introduced the name DCOM into the mix. It also got some great functionality such as Ethernet and TCP/IP. In 1995. It doesn't feel that long ago, but a lot of things were integrated into the DCOM and PAX. We have the ultrasound, we have the X-rays and radiation stuff that were added in imagery for the DCOM and PAX storage. They also decided to introduce the ACC. Committee includes American College of Cardiology. Try to say that fast 3 times. In 2000, they did a little bit of security. A lot of more devices were added, and a lot of more of X-ray methods were added. But they added secure communications. That meant TLS. The road so far for 2019. Now they have awesome real-time streaming. They have DCOM Web, which I haven't looked at, by the way. So if you feel like you have a COVID time, then take a look at that. And this was a huge leap in tech. Imagine from 1998 or 1988 until now. It's been huge. How does this all work then? We have a lot of protocols in medical field, and you might have heard of HL7, which is Healthwise 7, which has been on the carpet before. We'll come to that as well. What happens is an order comes in from the HL7 that actually goes to the exam and the imagery being taken. Once that is done, it ends up on the PACS for storage and archiving. We then have the viewer, which could be anything from an iPad to an Android phone these days to a laptop or a console at the hospital, where the doctor can go through the images and share it with his colleagues and get professional opinions. Yeah, decom and viewing. Today, experts across the globe can actually share an image to a doctor that is sitting on a beach in Aruba with his mobile phone on vacation to get his professional opinion. Or if you break a leg or have a very nasty break, they can send it down to an expert in Australia. And he will take a look because he's used to these types of, bone-breaking experiences. What we also have is in DCOM, which is a protocol as well as a file format, is something called IODs. We'll get into IODs, but today DCOM is still evolving, it's still moving, it's still something, as you can see, with the web. And this is something, especially today, that we can't live without. As stated before, DCOM is more than just an abbreviation or a word. It is a file format and a protocol. And that contains, it works as a container. Imagine like a Matroska protocol, MKV, where you actually have text in one and you have the images and the 3D stuff at one, and then you package to an MKV file. It's somewhat the same. You have the DCOM format where you have a lot of data and you have the imagery and maybe some other stuff, some 3D. So it's a package that you get. And this package gets stored on the PACS server. Stuff that is in the IODs, which stands for Information Object Definitions, another 80s acronym. I'm not bashing it. I mean, if you can remember it, it's very good. I can't. I would call them objects, so you know what I'm talking about. But in these objects, you have, for instance, patient names and the social security number in some cases, and other stuff, so at which hospital, which device, which doctor did the call, and which doctor took the X-ray. So all those things are stored inside the DCOM. So you both have the image and you have all these things that are stored. I should have done that at the same time, shouldn't I? So how does this look then? It has a unique identifier like 0010, 0030, and that is a DCOM standard for patient's birth date. And as you can see highlighted in red up there and the value downstairs, that is the patient's birth date. And those are the IODs that I'm referring and talking to. And body parts exam and even outcome. We've seen stuff where the doctors actually put in that the patient sadly has passed on. And here's the old me again. Where's the beep up? Where did things go wrong? So far, so good. And I wouldn't be standing here unless there's something wrong. I haven't talked much about security with the DCOM and PACS. Because what you saw in 2000, that's what I was able to find, the TLS. And there might be medical experts here that says, no, we get username and passwords. Yes and no. But there's nothing that really says security. So what if someone obtained a DCOM file? For instance, what would they find? As we stated before, we have the objects, we have the birth date, the doctor, the information. And sadly, I haven't gotten any response from the patients I've contacted. I reached out to a former FBI agent. I don't know if that was a smart move. Whose X-rays I found online in order to get their opinion on what they think of the whole situation and what their reaction would be. And how they can see it fixed, and mainly their reaction to it, because we need to get this thing off the net. I also reached out to a famous actor in the Orange is the New Black. He has been in the movies Taken as well. I'm not getting any response from these people. I mean, it's... I had prior, I started this research back in 2017, and prior I reached out to a Greek woman who didn't want to be featured, but said that this is shit, this sucks, and this is bad, and she's going to talk to her hospital. The server is still up, so I don't know how successful she was. GDPR. Let's do our paperwork. I'm not a big fan of GDPR, but maybe it's not your favorite topic Saturday afternoon around 1400 hours, I know. But I'm going to ask you, see if someone can answer. Who is responsible for your x-rays? Feel free to put your hand up, and nobody knows. Is it the hospital? Yes. Is it the specialist, if you get transferred to a specialist? Yes, maybe, perhaps, who knows? So what does GDPR say about x-rays? I'm going to do a little brain fart here for you. If an x-ray is done at the hospital, it's the hospital's responsibility, unless the hospital transfers it to the specialist, unless you're going back to the hospital again, because then it's the hospital's and not the specialist's responsibility. To break it down a little bit simpler, if you're at the hospital and doing an x-ray at the hospital, it's the hospital's responsibility for your x-rays. If you get temporarily transferred to a specialist, it is still the hospital's responsibility. If your end station is the specialist, so when you're done with the specialist, you say, thank you, I have no more pain, I'm ready to go, then it's the specialist that actually handles the x-rays and is responsible. And that is a big problem, as you will see, because nobody really knows. Looking at the EU and the General Data Protection Regulation, link down below if you want to check the sources. This is what it's supposed to be. Access currently regulated by local rules, hospital, administration, or national authority. GDPR covers biometric data, genetic and images, nerves, and unique information. GDPR actually covers your nerves as well, because like everybody, your nerves are unique. You can be identified, so that falls under GDPR. Also, you have the right to be forgotten. You have the right to call up the hospital and say, remove my x-rays. I don't want to see them anymore. I look horrible under an x-ray camera. But, yeah, who has done that? Your rights, according to DCOM and GDPR, you should have explicit consent to handling your data. That means that if they want to store an x-ray of you, they need to have your permission. If, crazy, if they are providing access to this x-ray from a specialist, especially once a viewer, still need your permission. And of course, there are additional laws depending on which country you work in or live in or getting your care in that handles that and should be a part of the whole health for that nation. So, raise your hand if you have ever been asked consent to store your x-ray. Okay. Raise your hand if someone has asked permission to transfer your x-ray. One. You rock, sir. That is, I've never seen that. I expected more hands, though, so I'm a little bit surprised. Raise your hand if you got a question if they can store your x-ray for a longer period of time. Okay, cool. I'm just curious. This article I linked to, which contains the GDPR in DCOM and PACS, is from 2017. So this is something that should happen. I know from my fact, personally, when they did an X-ray of my head, there's nothing wrong, don't worry. Nothing physical, at least. They didn't ask anything. They took the X-ray, the doctor checked it, and he said, thumbs up, you're good to go. That's it. Never got to sign anything. I never got the possibility to store it or retrieve it, because wouldn't it be cool if we got our own X-rays as well? It's like, hey, Mom, this is me. Like a photo album, that would be cool. Because I would like to see my X-ray. I haven't, until I started this, I haven't seen a single X-ray more than movies, and I would like to have my own. So let's talk about the elephant in the room, yeah? Security. The main reason I omitted security from the initial slide is that, in my opinion, there is none. And this has been covered before. I know, copycat, la la la. No, this was actually done at DEF CON. I think it was, someone covered it in 2017 for the Health Light 7, an internal protocol for writing subscriptions for medicine. There's also been some internal scans for DCOM at the hospitals. And I think the talk is from 2011, where it says, "I'm not a doctor, but I play one on your network," by Tim Elrod and Stefan Mori. So you can definitely check that out. It's mostly internal stuff. What you guys all came here for, right? PACS. Remember what it stands for? Picture Archiving something. Let's call it a storage server, okay? It resides on TCP port 104, 2761, 2762, and 11.11.2. And that's how I remember it, at least. And yes, it's open. Accessing a PACS storage server is as simple as these steps. An IP address, of course, you need that. The service needs to be open and running. You need a viewer software, and there's plenty of them. Most are open source. I have one on my iPad, for instance. You can use that, your iPhone. Mobility is really the key here. You need a AE title, which is your unique identifier, at least according to specifications. You can write my iPhone, my tablet, Mr. Gray, if you would like. That is totally fine. And you should use the command cget. You can actually choose that in the DCOM viewer, and not cmove. Cget makes a copy and gives you the copy. Cmove, yes, it takes it and moves it from the server. That is very bad, because then it's non-existent in their PACS server, because you moved it. Other cool names you can write in the AI title: Dr. Phil, Dr. House, Shredder. Just looking at the notes, really cool. So not all PACS or DCOM viewers are created equally. In my research, I stumble upon some that work, some that don't, some that work from certain occasions, some that don't work. So you need to have a whole slew of applications. I have stuff running in Windows, Linux, OS X, iPad, iPhone, and if you're unable to retrieve something from the iPad, then you should try the iPhone with another application. That works. And maybe try the Windows version, because it's a little bit wonky. I failed to understand why. But the Linux version is the best, because you have no UI. You can just issue commands and just download whatever you like, if you should. I will not cover the specific imagery data that is in there according to DCOM, but you can add stuff like distance between X and Y and Z and depth and 3D. It's way too advanced. And then you can save that into the DCOM as a measurement, and it gets stored in the DCOM file so that other doctors can see, it's 3 centimeters. Some decom patience. This is actually from the iPad, and you gotta love my censoring. I just scribble over. On the list here we have the famous FBI agent, Susan, and one that I blurred completely because he's a famous actor, and he's on IMDb, and has been in a couple of movies as well. Sadly, still no response, and if there is a response, I will post it on Twitter for you guys, so you can steal my Twitter handle later. X-rays look a little bit like this. I've censored a lot in due to respect to the patients, since this is a little bit close to home. This is uniquely identified to this person. So if this was used in a GDPR case, that person's specific nerves that you see identifies, I'll say her, identifies her. Even if you have to go through 5 billion other X-rays in order to find a match and find her, sure, but it's unique to her. Viewing on an iPad. I cropped it a little bit just to hide the name. Again, we have the ability to view. We have the ability to use tools to measure distance. We have the ability, if the decom viewer is advanced enough, to go in 3D, if it was a 3D scan, and see the brain and go deep into the eyes and see all the layers. And it kind of works, I imagine it like a GIF, don't slaughter me, where you have several layers that you actually can animate, and you can go through each layer and see. So it's really good covering like tumors and stuff that is problematic. And for some of you that saw the last picture, who might be a doctor, might have seen something strange. And yes, there probably was something strange with that person on her X-ray. And I hope that that's not the reason why she's not communicating anymore. Let's talk about exposure. Because by now you all figure out that this is not just internal stuff, this is on the internet. What I've seen happening on the internet is a lot of things go up and down. That is, things get moved. So I'm thinking a portable storage server gets moved to another location, loses its IP, and then comes back online at some other point in time. But it's been, it's crazy out there. Current exposure, as of yesterday, after 2 beers and 1 cider, 2,839 PAX servers. And you're thinking, it's a low number. Yes, it is. But the amount of patients in these servers can be 1 million per server. So now we're talking in context that it's a lot of people on these servers. And not just people, they're X-rays of animals, if your dog breaks a leg and goes to the vet, it can end up in an online PAX server. Not as bad, but animals have rights too. But 2,839. Let's check out the top dogs in EU. Germany, first place, 163 PAX servers. And this is fresh off the press, like yesterday. Italy, third, with around 30. France takes the second place with 44. Netherlands is tied with Italy with 30, which was a bit surprising to me, seeing like the size of the country compared to the amount of PAX servers actually done. And I hope I didn't color anything wrong because I used the template. I'm sorry, I'm lazy. US in the world is the top dog, and they have 753 as of yesterday. India, 404, and Brazil, 178. India was a bit of a surprise because usually when it comes to IoT, they're not that forward in other protocols that I've seen. but in decom. And there might be a reason for that, and we'll come to that in a little bit. I just have to give a shout out to John Madley, the creator of Shodan. Shodan has disabled the ability to actually go through historical records to see how it looked before COVID hit. But selling my soul to John and promising Anders von Asset Security as a gift, he agreed to provide me with some data, which we can see. And below is the Shodan search term that you can use in order to find the exposed packs and see for yourself. Historical data, number one. I know there's a little hiccup there because I guess John was drunk during 2018 and didn't collect any data. Might have been the same time he got the Husky, I'm not sure. But something happened. But as you can see, what happened in 2019, guys? For those, you all know, COVID hit. We actually got our first good look at the COVID virus in 2019. And as you can see, there's a big increase in the exposed pack servers during that time as well. Some more historical data, as you can see. I don't know if it's clear enough. I know the graphics is a little bit wonky, right? But you see where we're at now. We see April, we have a upswing in exposed packs storage servers in April. It's hard to actually find some good graphs to use when it comes to COVID and when it comes to, the virus, because everybody's got their opinion and their spread and per country and how many are infected, how many dead, et cetera, et cetera. But I found one. Forgot to include a source here. Sorry, my bad. But it's Statistica something, where you can get statistics. And this is actually the spread of COVID. Should be worldwide. And if you look at, what is it, April 2021 here? There's a little bit of upswing, and the same thing you can be seeing for the exposed pack servers. So my guess is the mobility is key factor. Being able to bring this on locations and make sure and see if the patients are doing good, how their x-rays are. In some cases, if they survive or not. So more data, April 2017 to August 2021. A little more closer look. United States, India, and Brazil. Iran, China, Canada, Korea. And remember, one of these servers can host millions of patients. So what else can we use this for? What else is there? I mean, I see people's x-rays, but now what? I always save the best for last, don't I? So let's talk about other attack surfaces. What I didn't include, or didn't say, or omitted from the beginning, is that you can overwrite the x-rays. You can take any x-ray there is, add stuff to it, upload it, overwriting the original. You can download and remove, you can delete, or you can download the x-rays, edit the Photoshop, and remove those black spots that the person have on their lungs. Re-upload and say, yeah, you're doing great. Not only that, I know, can it get any worse? Back in 2017, there was an Israeli research team, link included, that actually made a malware that uses AI and that can be unleashed internally to scan these decom images and trying to find x-rays of lungs. And once it finds x-rays of lungs, with the AI algorithm, it could add black spots or holes in places. That would mean that if that spread internally at a hospital, a lot of people would be going to chemo that year We can make it worse, though. We can remove the spots, as I said. Imagine a presidential candidate going into election, and he has a disease or does not have a disease. We can alter that in any way. So he can pull out of a race saying that, no, I'm sorry, I'm very ill. I need to tend to my family right now, and the time I have left, but there's nothing wrong with him. Or just have him like, yeah, no treatment, just remove whatever we see on the x-ray. To put this into a money perspective and be a little crazy, as they say, what about your favorite athlete? Let's see, American football, he gets an injury, slam, he's down. They pull him out. Tabloids, within the same minute that he got his x-ray, would say his career is over. Or some celebrity, a royalty, gets in a car accident and they have the x-rays. Imagine the worth of an x-ray of a royalty that you can sell to a tabloid saying, this is Prince XYZ's x-ray. He broke his neck. Or he broke his, that was a little abrupt maybe, but broke his arm, broke his collarbone. Or add some spots and say he got cancer. Sorry, he's not going to make it. As it couldn't get worse. How about using these DCOM images as actual command and control points and servers? There's some research about a guy that actually made a portable executable, exe file, inside one of these IoD objects. And not only that, what if you can have instructions what's going to happen next in the command and control infector servers by having it communicate to a DCOM server and a specific patient and a specific ID, let's say patient number, and therein is the instructions on what to do next. Go and download XYZ, or download from even the same table. Download from the patient's birth date the next malware that you're going to use to infect. So you can use these as spreaders, and this is actually going on as well, mostly internally. So patient's name or even the device name gets renamed to base 64 encoding that contains malware that can be used to further spread inside the network. As before was a long rant, this is going to be a bit longer. When things aren't easy, it's a bit insecure. With easy, I mean the DCOM and the PACs are supposed to be plug-and-play devices. You're supposed to be going to a network, plug in your X-ray machine, it finds the PAC server, that's it, good to go. When it's that easy, it usually lacks security. This is a standard that was developed in the early 80s. And slapping security on top of something that has become de facto standard is a bit hard. You can't just start adding usernames and passwords. What about that 4-ton or 7-ton, 400,000 euro X-ray machine that is end of life and that it can't use because you upgraded PACs and it doesn't work like this anymore? That doesn't fit into the hospital's budget. So what needs to be done and what we need to help each other with is to actually get this protocol and this standard more secure by using the old protocol on top, make sure that it works, but at the same time helping DCOM and helping hospitals develop and host things secure internally. It is, this presentation was a bit hard and a little bit close to home. We need to do something together, and I'm not here to kick the hospital scene. I'm not here to do what I usually do and say, ha, insecure, pwned. No. They saved our lives for 2 years now. It's time that we actually save theirs a little bit. So if you can do any work, I don't have the connections, but you probably will. If you can do any work, and you can do it pro bono, and you can show the medical field that you're actually not that bad, help them set it up securely. Help them remove this from the internet. And this is really hard when it comes to the cloud, because a lot of people are moving stuff up on the cloud and you can't know which hospital this X-ray belongs to, who to contact. But if you know someone in the hospital field, talk to them, see what they can do. I kind of omitted I hear a question. I hear, how about Sweden? We got 4 exposed. And people are looking down, but don't worry. They had no customer data for now. They might have. Unless they work as a transfer hub for transferring from PACS to another PACS. Because that is the whole purpose. Being able to send things from A to B or A to C. Like a plug-and-play protocol. So again, guys, please help out your hospitals, help out your people. This is bad, I know, but you know, they saved us. It's our time we save them. We're a little bit short on time, or more time, but that's a longer break for you guys. So feel free to ask questions, to reach out, to do whatever you like, to hook me up with some hospital people. That is also fine. I'm not trying to bash hospitality. I'm trying to help. So the more you can spread this and spread the love, the better. Thank you.
Dude, that's heavy. That's bleak. And okay, I don't even know where to begin. You said there's no authentication into any of this.
No.
You said that you talk to people and they say, "But we have passwords."
Yeah, that is mainly due to their hospital application requiring them to log in. So that's another layer that they have to jump in order to reach the PACS, but we don't.
They're talking about Windows login to their.
Yeah, exactly.
Fantastic. So yeah.
And that leads to a question.
Wait. You're but you have to give a name, but the name can be anything.
Yep.
And there's no like access logs or anything.
Nope, I've seen no.
Okay. And everybody knows about this already because nobody talks about it.
Yeah, everybody knows, nobody talks about it. There's been some article out. I've been featured in some of these articles, just for a 4-liner. I had this much to say, and it was comprised of four layers. But you know, it's been covered in DEFCON, Black Hat, RSA, mostly internally. But how about external? As we can see, we can just pop in and get some X-rays, and that is a big problem.
And that leads to the first question from the audience. Is there any like secure PACS or any plans for a secure PACS?
I mean, one of the slides I have, we actually had what they say you should do, and it actually includes hosting it internally and VPN. Sure. But who enforces that? Even if there's a standard, as we can see, even if there's rules and regulations, as we saw, they're not doing it. Why? I think simplicity. They want to be able to, it just works, pull up my phone and connect to the server and download the X-ray. I don't have to jump through this WireGuard VPN or this OpenVPN and certificate and usernames and password. I just click once and I have the X-ray. And I think that needs to change a little bit. We need to have some sort of authentication. Just connect to the hospital VPN. Then you can reach the PACS server and see your. So that's my 2 cents on it, at least.
You said retrieve them, update them, move them. Could you also add them?
I can probably add, yeah.
So but the Swedish ones, I mean, they're empty. You said there's nothing on them.
I haven't tried to write because that would be very bad if I were to do.
I mean, it's already bad, right? But yeah.
But yes, you can probably add. So you can add add patients' data.
So you could add somebody in there, probably.
Yeah.
Well, if it, you know, they'll get transferred. It'll get transferred to another server that presumably is not online then.
Yeah, exactly. Maybe it could be something like they just have it as a bounce host. So they put in patients and then they get automatically transferred to the specialist. So if you put in Björnes Magasin, eller Bamse Killing, whatever thing, maybe that will end up at some specialist trying to examine your favorite cartoon's leg.
Awesome. Audience questions?
One question is like, if looking at these at Shodan, do you think any of them are honeypots, or have you researched that they're actually legit and contain data?
Come again? If they're
you were saying that it's like there's a lot of Shodan on these ports, but have you verified that they're actually real servers and not just honeypots and stuff?
Some are honeypots, yes, they are. Those are actually marked as honeypots as well in Shodan to some extent. Okay. Some of them have been excluded. Some of them can be testing, some of them can be cloud testing. But you can easily make a small script in Linux that connects to each and every one of these and just downloads the first patient in the table. And then it says, done. I didn't include that script, but it's easily like 5 lines of bash with the tools that we have at our exposure. And then you can probably get the real number unless it's a honeypot that actually has fake patients. And we see a lot of things moving to the web as well. So we see a lot of web-based decom viewers popping up, which probably is going to be a problem. Probably a problem. It's going to be a problem. Especially after having thought about security and actually communicating with a real PAC server in the back end. It's a whole other level of hurt.
Yeah, it's bleak. Okay. Do you have any more questions from the audience? 'Cause I don't know. It's like, it is as bad as you can imagine, and then, yeah, then it's just really bad, I guess.
Yeah, so the message is, come together, let's fix this, honestly. Coming from me, coming from one that usually don't give a shit, I'm giving a shit. So, and I hope you guys do too.
Well, but put it this way. Okay, so if the 4 Swedish ones are actually part of some datasluss, whatever, method of transferring to a more secure or handling it in a more secure way, then I'm sure that the hospitals didn't think of that themselves. I'm sure that there's maybe someone in the room that built that up for them. That this is an effort already to do something.
Yeah.
Probably trying to figure that out, and if they're trying to help other countries as well.
Yeah.
It's a good way.
Yeah. I think it could be like local IT or something, just setting something up real quick, or not knowing what standards or protocols to follow when it comes to medical devices. But in the end, it's your X-rays, and as you say, you have the right to be forgotten. Talking about GDPR, by the way, and how much this would cost in numbers. I mean, if all your information is there and you're identifiable, nerves and everything, so like what are we saying, like $1 million per person in the system? I mean, if GDPR would slap their hammer, they can take down a country. If we will look at Italy and say like, yeah, you have 13.7 million people in the PAC server, and all of them are saying GDPR, GDPR, you need to be punished.
Yeah, but what happened about the, was it 1.5 million phone calls recorded in the 1177? Yeah, what happened with them? I didn't hear about any money anyway.
Nope.
Just the cable. Lots of money? All right.
Lots of money.
That maybe someone couldn't pay anyway. So. All right. Thank you very much, Lucas. I'm sure there'll be more questions privately after this.
Sure. Hit me up after I'm here. I'm going to go grab a beer. So thank you, guys. You rock.
Thank you. Next talk is at 3:30. So go have coffee. There should be something to eat as well. And I'll see you back here in, I guess, 45 minutes then. and we're perfectly on schedule. And everyone's sitting down or found the TV, I guess. So I will just hand the stage right over to Leif Nixon. Welcome.
Thank you. Oh, I'm Leif Nixon. I have been doing things to computers for many years. These days, my daytime work is at Sectra Communications in Linköping, where we monitor and protect critical infrastructure, the industrial control systems in important places. But a fun thing in the light of the previous presentation is that our sister company, Sectra Medical, is one of the leading vendors of PACS systems. There is a reason why there are only 4 visible PACS servers in Sweden. It's because we have shut them down. So there are people actually looking for these things. But anyway, over to the French case. I mean, the title in the agenda says tainted crime scene because I had to have something more descriptive. But me and my former colleagues always refer to it as the French case. This is when I was working in academia at the National Supercomputer Center at Linköping University. But to give some context, we have to go to Geneva. This is an aerial picture of the outskirts of Geneva. You see Lake Geneva in the upper right and the airport to the right. The white circle is LHC, the Large Hadron Collider. It's a tunnel about 100 meters underground where protons are accelerated to near light speed in both directions at once through the circle, through the tunnel. And then these bunches of protons are intersect and collide at 4 places around the ring, the 4 experiment sites, which are the names. The yellow line is the border between France and Switzerland, which has interesting legal complications. I could talk for quite some time about LHC because it's a very cool place, but I don't have time for that, unfortunately. The thing you need to know is that LHC produces data, lots of data, humongous amounts of data. CERN itself can't take care of all the data, so there's a global network of tier 1 sites on almost all continents that cooperate to store, receive, and store the data when the accelerator is running. And the GF down at the bottom left is the Scandinavian center for dealing with this. So there are typically dedicated 100 gigabit lines between the tier 1 sites. Underneath the tier 1 sites, there's the actual research institutions. There are many, and they are interconnected in complicated ways. This is a very large system. So how do you actually deal with this complication? How do you let the end users, i.e. researchers, actually operate the systems, access the systems? Well, there's something called the grid, a computation grid, where a high-energy physicist, like Tord Ekelöf at Uppsala University, wants to run a computation job on CERN data. Well, he writes a job description. I want to run this executable. I need this operating system, this much amount of memory, this runtime. I have these input files, and I will produce these output files. And then he sends them to a workload management system, a kind of a job broker that checks all the various systems and decides to send it to maybe NSC, my previous site, where the job runs. It sucks in data, probably stored on tape, maybe at Fermilab in Chicago, and the output will perhaps go to disk at Ian de Petrois in Lyon. Altogether, there are about 170 sites in 42 countries and about 1 million compute cores. So security is kind of important here, because not only are the computation resources valuable in themselves, if a bad person gets access to this, they could do quite a bit of damage on the internet just by using the network, all the resources. So what about security? Well, each region in this collaboration has 1 to 2 security officers. Some of them form a group called IRTF, the Incident Response Task Force, which I used to lead. That was quite interesting. It was about 10 people in a global distributed team. Many languages, many different cultures. It was really fun. And we had lots and lots of security incidents because, well, from 170 sites, everything rippled up to us. And of course, there were security incidents. But there were kind of, okay, somebody stole a password and logged in via SSH, local things. Nothing really related to the global infrastructure as in itself. Until 2014, in January, when site admins at BNP in Lyon discovered that a number of running BLAST jobs, a proteomics software submitted by a French user that we will call Paul, because that's his name, were behaving strangely. They were doing integer calculations instead of floating point calculations, which you would expect. So that was weird. So they took a look at the binary itself using lead methods like running strings on the binary. And oh dear, this is a Bitcoin miner. It's not supposed to be running on our supercomputer. Looking back in accounting, there were 35,000 jobs, individual jobs that have been submitted over a couple of months, several different sites, about 100 CPU years, at the cost of about I think I'm missing a zero there, actually. Well, the electricity and cooling and stuff for these were quite a lot. He had made an order of magnitude less money from the Bitcoin than it cost to run the resources. But of course, he didn't pay for the electricity. So we followed our procedure, suspended Paul's grid access since it was apparently compromised, sent out an alert, look for strange jobs, and yours truly was appointed incident coordinator for this. And this was this is the first real grid incident. So imagine klaxon sounds and red flashing lights. The computer that had sent these jobs was inspected by the local sysadmin at that site. It turned out that the sysadmin was actually Paul himself. He sort of moonlighted as the institution's system administrator, apart from being a biochemist. He found that the computer was compromised. It had various malware installed, including a rootkit, and had logins from China in the logs. So he proceeded to say, okay, sorry about this, case closed. Well, I wasn't totally happy with Paul himself investigating this. So I wanted to check for myself. So I wanted access to the compromised machine, or at least the disk image. And for me, sitting in Linköping, Sweden, convincing people in France that they should send me forensics data is maybe not so easy all times. But you know, the people joke about French bureaucracy. They're all true. This is the structure of the French research and educational structure. There are multiple different ministries involved, for instance. Information security is under the Ministry of Economy, but IT security is under the Ministry of Education, just to start with. So this took a few days, but eventually I was actually sent a 19 gig disk image, and I had a nice grid infrastructure to transfer the data. and I started looking at it. So what do? Well, you look at the file system timeline, and you look at the system logs. So we need to talk a bit about file systems. This is a sort of simplified model of a file system, a typical file system in basically any operating system. You have directories where you have the names of files. To the left, they have pointers to inodes, data structure which contains the metadata about the file, things like the owner, permissions, and various timestamps. There are many different timestamps usually, depending on the file system, and eventually pointers to the actual contents of the file, which lives separately in different disk data blocks. Okay, so timestamps. Well, there are typically, well, the three sort of fundamental types of timestamps are that you deal with in Linux and Unix is mtime, that's the modification time of the file, the last time the file contents changed. You have the ctime. This is confusing. You have both modification time and change time. Ctime is change time. That's the last time either the file contents or the inode changed. So contents or metadata, that's ctime. And atime, the last time the file was read. Important piece is that mtime and atime can easily be set to any value. You just use bin touch. But ctime can't easily be changed. There's simply no API for it. It's supposed to be kind of tamper-proof. Okay, so when you have all, well, to generate the timeline of the activity on the file system, you grab every single timestamp in the file system and sort them into one big list. This is lots of data. Lots and lots of data. I mean, 19 gigabytes of data, many thousands of files, and you get at least 3 timestamps per file. So lots of data. But, well, you learn to find the interesting bits. And there wasn't much to find, actually, in all this data. One can establish that on November 29th, the previous year, the system had been installed. That was a Friday, I think. So the next week, we see the first user activity. Paul logs in, sets up the environment for submitting grid jobs. And then, just after he logs out, there's malware popping into existence in the file system with no trace of how it actually got there. And this is a bit disappointing, but that's how it is sometimes. The timeline only gives you a limited view of what has happened, because if anybody has touched those files later in history, I mean, you only see the last timestamps, so it's a limited view. And on January 9, the system was shut down for the last time, and not much else to be found in the timeline. So we look at logs instead. But, I mean, this is presumably a root compromised system. Can we really trust the local logs on the computer? Well, it's hard to say, but you can at least look for obvious signs of tampering. We want to try to build a narrative of what has happened to this system. How did it end up in this state? Try to take all your observed data and put it into a story that seems credible and that explains everything about it. As you know, security-related events are logged to varlog secure on a Reddit type system. And to stop it from growing too big, you rotate it. And you know the log rotation process. You have one live log file, varlog secure, and then you have archives, a number of archive files with the older logs. And then once a day or once a week or once a month, you rotate them. So you remove the oldest file. You rename the second oldest file to the name of the oldest file. So you end up with this, you see it. You do this whole chain. In particular, this means you rename every file. Every log file is renamed when you do the rotation, which means you change the metadata, which means you get a C-time update for every file. And since this is a fast process, the timestamp should be the same within a second. And the time of the last rotation. So, what were the C-times for these rotated log files? This isn't close to being the same timestamp on these files. This is very, very weird. There's no easy explanation. How could we get into this state? How could the C-times end up in this way? It doesn't make sense in any way. In fact, this is actually where I realized that, okay, something is really weird. I can't explain this. There is something very strange going on. Okay, but timestamps are weird. Okay, but let's look at the contents of the logs. Remember there were logins from China? Well, they were there. Root logins from a particular IP address, which is allocated to China. But at the time, it wasn't routed. It hadn't been taken in use. There's no way you can make a TCP connection from that IP address to the computer in France. Weirder and weirder. This log line is obviously totally fake. So, at this point, is there any trace of truth left? Is this just lies, all of it? Okay, can we find something that has not been tampered with? What about deleted files? Well, what happens when we delete a file in a Linux file system? Well, this is the same picture as before. What happens when you delete the file is that you simply remove all the pointers, zero them out. All the data is left, but you can't puzzle it together. To be able to reassemble the file, you need to get back those pointers to the data blocks. So we must find an old copy of the inode. But how can we do that? Well, let me sidetrack for a moment. In this deletion operation, we change a lot of pointers in the file system. What happens if the computer crashes in the middle of this update? We will end up with an inconsistent file system. That's a bad situation. So in modern file systems, there is a data structure called the journal, where every write operation is recorded. This is, again, a sort of simplified model of how it actually works, but basically it's a list of records saying that I intend to write this data to this disk sector, and then the computer does the actual write operation, and if it was successful, it goes back and checks that off from the journal. So this, if we are lucky, there may be a copy, an old copy of the inode still sitting in one of the old journal records. If we are lucky. I mean, and there are tools for doing this. X3 undelete and similar, which I obviously tried, but didn't find anything interesting. That I figured that okay, maybe the tools are failing. Let's do this by hand instead. So I extracted the journal and took a look at it, and that was kind of surprising because in the middle of the journal it started containing timestamps for each record. At the time, that was a really new feature in the Linux kernel. It wasn't present in the 2.6.18 kernel that the computer had been running. So that was kind of what? And you know what else? The computer was shut down on January 9. How can we have timestamps saying January 10 in the file system journal? So, I mean, And when I did a double take and checked the timeline again, I realized that, oh, actually there are records at the end of the timeline that actually says January 10. So I could confirm it, that stuff had happened. Also, the super block of the file system has a timestamp saying when was the file system last mounted, and that also said January 10. Even if you mount the file system read-only, that timestamp is updated. Okay, so let's look further at the rest of the file system journal. Now, this is really strange. Again, I mean, these records are created sequentially. The timestamps are supposed to increase monotonously. I mean, time is supposed to just go in one direction. But actually, they were jumping all over the place. And now this is starting to get almost spooky. What the F? And finally, cross-checking all the data once more, the weird timestamps in the journal all of them match the points in time where malicious artifacts had appeared on the computer. So there is only one narrative that fits all the facts, that on January 8th, malicious jobs were discovered. Okay, so Paul shut down the machine on January 10. But on he shut them down on January 9. On January 10, somebody that had physical access took the disk and mounted it on another Linux system with a newer kernel and started writing data to the disk. And to sort of try to make everything look correct, he changed the system time back and forth on the computer while doing the writes. That's why we have all these really weird C times and why we have the really strange journal. So this was, as far as I can tell and as anybody else can tell, this is actually the truth of what happened. Did Paul get convicted is the next question, of course. Well, I sent a report to the French university. They had a 3-person committee that evaluated it very carefully. They agreed on the technical evidence, but they didn't agree that they could indicate one single person who had performed this, even though it was only Paul that had that physical access. So they didn't agree that it was him and wouldn't go to the police with it. Why? Well, the committee consisted of an IT security representative, information security representative, and a local representative, Paul. So no, he didn't get convicted, but I take it his science career hasn't been doing great since this point. So what is the takeaway? What is the point of all this? What do I want you to take home from this? Well, no. Okay, first of all, don't try to steal CPU time from a supercomputer. It may be tempting, but those are actually basically the only kinds of computer in the world where people are actively monitoring CPU usage and will react if things look strange. Go for office computers or something instead. Secondly, and more importantly, is that it's to credibly fake complex digital evidence is really, really hard. Some of us know this. If you have done a forensics training, for instance, and you want to create training materials and make it look good, that's very hard to make it all consistent. When I do that, it always ends up with somebody in the training coming up with, well, why does it say Nixon owns this file in the training material? And that's actually a positive thing. Because in this age of disinformation and claims that, oh, no, it's just a false flag operation, it's not Russia, it's Ukraine, or whatever, you can actually find the truth, even if it's just digital data that can be easily manipulated. You can still find truth. And that's something which I find makes me feel a bit more optimistic than usual. That's it. Thank you very much.
All right, thank you very much, Leif. I don't know if we have questions from the audience, but maybe we have like 1 minute for it.
Actually, we mostly have comments, but like they should have mined Monero instead.
Yeah.
It didn't exist back then.
1,000 comments like, why didn't you do this? You should have done this. They should have done this.
Yeah, we also shut down his mining pool account, so he probably lost his Bitcoin.
I have one relevant question. Would it have been better to just wipe all the logs and try to wipe the disk before sending it to you?
Yes, but it would have. But he had already told us the fake story that with all the SSH logins and stuff. So he had to, when I insisted on getting the disk image, he sort of had to recreate his story. Okay.
Yeah.
Thank you very much. I'll be around.
We have the next talk begins in, is that 15 minutes?
In 15 minutes.
15 minutes. We have Vesa on stage, so stretch your legs, have more coffee. All right, we're going to continue with the last talk of the day, and then we're concluding. So I hand the stage over to Vesa. Welcome.
Thank you. So my name is Vesa Virta. I am a museum guide at the FRA. And the FRA is, of course, Swedish National Defense Radio Establishment, which is the Swedish Signals Intelligence Agency. So I'm here to talk about our latest crypto achievements that we can talk about. But yesterday I had a discussion with a colleague, and we realized that it's actually not the latest. It's the latest but one, because we broke something else that we could talk about. But I'll save that for next year. So I'm here to talk about the Geheimschreiber, of course. There is a joke saying that during the Second World War, Norway was invaded by the Germans in a matter of days, Denmark in hours, and Sweden over telephone. So Denmark and Norway were attacked and occupied. But Sweden wasn't attacked, but I mean the Swedes had quite extensive trade with Germany, and they made a deal with the Germans so allowing the German soldiers to use Swedish railroads, which was also expanded to transport cargo as well. But that agreement was made like 3 months after the invasion. About the same time as the invasion was that the Germans sent a demand to the Ministry of Foreign Affairs in Sweden, which basically said, pretty please, with the cherry on top, could we use your telecommunication cables? But my German isn't that good, so maybe it's because it's in German, but the pretty please and cherry part wasn't in there. The Swedish response, well, the Ministry of Foreign Affairs, they had no clue. So they went to the military headquarters and asked the commander-in-chief, how should they react to this request or demand from the Germans? And the commander-in-chief, he went to the commander of the signals detachment, and according to the legend, his response was, protest like hell, but thank God for this opportunity. So, the Germans were allowed, they were given control over the cables on April 14th, 5 days after the invasion. But there were wiretaps installed, and from the start, it was ordinary teleprinters installed. So everything that was sent over those cables, a copy of that was sent to the Swedish intelligence. When the Germans started to use the cables, they started with plain text communication, but they talked about their Geheimschreiber. And one day, a message like this came through, saying that here MBZ, QRV, meaning that this is station MBC, or MBZ. QRV is Q code, used in radio communication, meaning, do you hear me? And the response was KK, meaning sure. Then this QEP code, followed by 5 numbers, and then which is short for umschalten, which means turn over to the other mode. The response was VV, short for verstanden, and then came cryptotext. The code used, I mean not the crypto, but the code, was Baudot code. It was 5-bit codes, and 5 bits, it's enough to do every letter in the alphabet, and then you have some. But it's not enough to do every letter in the alphabet, all the numbers and special characters. So what you did was to have two different modes. So you could have a letter mode or a figure mode. And you could shift from letter mode to figure mode when you use the numbers, and back to letter mode when you were going to use letters again. When they started to send crypto text, the Swedish intelligence had to change the interception device to produce all the characters and not put in the blanks where there was a blank and space and so on. So they made a device that stayed in letter mode all the time and changed the control characters, like character turn, line feed, switch to letter mode, switch to figure mode, space, and null. They changed that with the digits 1 to 6 and stayed in that mode all the time. So this was what the message looked like after the new improved interception machines. So you see the here, and then the space. And the space was represented as a 3 and a 5. It was actually the 5 that was the space, but 3 was changed to letter mode. And the reason they put in a change to letter mode was because the lines were a bit noisy. So you could get some static or some interference. So if you got a transmission error and turned into figure mode, you would get gibberish. But if you sent switch to letter mode and space every time when you were supposed to send a space, then the gibberish would only be for one word. So what did the Swedes do when they received the crypto text? Well, they sent it to Arne Berling. Arne Berling, Swedish mathematician. He had done his military service in the crypto department. And when the World War II broke out, he contacted the military headquarters and said that he could be of some use. So he was connected to the crypto department or SIGINT department, and later on to the FRA. FRA started as an independent agency in 1942. After the war, he went back to Uppsala to be a professor in mathematics, and in early 50s he moved to the United States and was professor at Princeton. But he was working at the FRA or a consultant to the FRA during all of World War II. So the challenge he received was that he was given a bunch of crypto text, no context. He wasn't even told that it was German. He wasn't even told that it was a teleprinted traffic. But he checked through that, the telegrams that he received, and realized that there was probably some transmission error in it. So he went back to the main office of the crypto department and collected a few more samples from the end of May. Went back to the place where he was stationed out in Lidingö, and he worked on those messages for 2 weeks with pen and paper and a brilliant mind. Solved all the crypto and also figured out how the algorithm worked and how the machine was built. The message he received, or the conclusions that he made, I mean, he saw that there were 32 different characters, so 2 to the power 5, maybe a 5-bit code. Someone could have told him that. There were possibly some plain text messages, or at least in the beginning of the message, it was plain text when they sent the message key before the for umschalten. But probably he had some pure plain text messages as well, so he could see what would probably be in the crypto text. For instance, the QRV saying, "Do you hear me?" That might have been something that the operator sent right after the switch to crypto text. And there were retransmission and key reuse. So the operators sent different messages with the same key. So I'm convinced that there are a few people in here who could actually do the same thing as he did back then. But he did it back then. And it's a remarkable accomplishment. David Kahn writes in his book, Codebreaks, that this is probably the greatest crypto achievement of World War II. And this is how he did it. Pen and paper, wrote down the parallel messages, found out where you could guess that there was a space. And the thing is that the space was it was a bigram, so it was 2 characters. And when those were offset, he could kind of work on and find more and more of the information. So the machine that Germans used was a Siemens Halske T52. This was a machine used for strategic communication. It weighed about 100 kilos, and it was used from like the embassy German embassy in Stockholm eventually had one, and communication back to Berlin, and also the German troops from their headquarters in Oslo back to Berlin. So this wasn't like the Enigma where more or less every soldier had one. No, not really, but you get the idea. The Enigma was for tactical operations, tactical information, and this was more strategic. So Berling, when he thought about this, he realized that it was a 5-bit code, and how could you manipulate bits? I mean, in this room, and Abraham earlier talked about XOR being a good way to manipulate bits. Well, yeah, there was some XORing, but it wasn't enough. They also swapped the bits. So after the XORing, the order of the bits were changed. And Berling believed that that could be done with some kind of relays that either were open or closed and swapped or didn't swap. So here is a picture where 2 of the relays were open and 3 were closed. So when he did his, put up his parallel crypto text and tried to figure out where there could be something that he could work with, like the 3.5 and the QRV, and worked on making the plain text message longer and longer, he got to this kind of conclusion, where in the above part you see the XOR thing, and then the swapping of the bits. And when he had done like hundreds or characters or something, he saw a pattern. Not the pattern with what it was XORed with, but the pattern for each separate bit. So the first bit, you had a repetition after a while. Second bit, also repetition, but another period. And third bit, also repetition, but with another period. So he figured out that it was some kind of wheels or some kind of tape with different length that controlled each of the bits and each of the relays switching the bits. And he realized that you could build a machine to produce this kind of crypto text using 10 wheels with pins on it, for pin for 1 and no pin for 0. And the length or the number of potential pins on each wheel were different, and they were co-primes, so you wouldn't have a repetition until 893 quintillion 6. Yeah, you get the point. Compared to the Enigma, where you had the three 26-letter wheels, which would get a repetition after just 17,000 or something like that. So here is a picture of how the machine worked. You had 10 different wheels. You got some key material by checking if there was a pin or not in a specific position. And for every new letter encrypted, you rotated the wheels 1 notch. And it wasn't enough just to have the wheels. You also could change the ordering of the wheels. And that was done like every 3 to 9 days. They changed the ordering as well. By the small letter D, you have the plain text coming in, the letter R, 01, 01, 0. It got XORed with the 5 first bits, leaving 0, 0, 0, 1, 1. And then it went into the part where you could change the ordering. So what came out was 1, 1, 0, 0, 0, the letter A. The key management for the German operators, they had a message key, which they called the QEP. That was the one you saw in the first telegram or first message, QEP, and then they said the position of 5 of the wheels. And then they had a code book where they had the daily key, which was the other 5 wheels. And for every day, they changed which of the wheels was in the daily key and which was in the message key. So every day, the cryptologists at the FRA, 3 cryptologists worked for about 1 hour to find out the daily key, and then they could have production on the rest of the messages. The Germans improved the instructions for the operators, saying that they should choose a random word that they called a Wahlwort. So each message should start with a random word. For instance, Sonnenschein. Many messages started with Sonnenschein. Some messages where the operator got a bit creative. They used Mondschein instead. And then one operator got really crazy and went for Donaudampfschifffahrtgesellschaft Kapitän. And that's kind of a random word. But imagine that you're a cryptanalyst at the FRA in the spring of 1943, and you have seen all these, and you are working with trying to figure out the daily key for today, and the first few letters is Donau. Do you call that a jackpot? Because probably you're going to have quite a long crib. The Swedes hadn't seen a Geheimschreiber. They had only worked out how it was supposed to work. And Berling told an engineer from LM Ericsson how to construct a machine, or how a machine should work that could decrypt the messages. So he built what was called apps back in the day. And those apps didn't look very much like the Geheimschreiber, but they performed the same function. So with these, you plugged in the key, and then you could produce clear text. So production on these ones were from 1940 to half of 1940 to the end of 1943. At the peak, there were 32 apps running, doing the decryption of the machines, or the messages. Half of the staff of FRA worked with this, so 185 people back then. And they produced like 300,000 telegrams. And in contrast to how we do today, the messages were sent to our customers, to the military, to government in the original format. And in the 40s, in Sweden at least, you could assume that someone working in the government, they spoke German. So they got German messages. Today, any intelligence organizations would try to hide where the information comes from that they use in the reporting. So some of the results from these operations were like, they had good insight into German troop movements in Norway. So every time German troops came close to the Swedish border, there was some kind of military exercise on the Swedish side of the border, or at least show of force. So the Germans realized that Sweden wouldn't be a lame duck. And they also, the German military in Norway had also commented on this, that the Swedes were very vigilant and on their toes. The Swedes had information about the German invasion of Soviet Union. They knew it more than 2 weeks in advance, and they even knew the day which the invasion should start on. That information was passed on to the British ambassador in Moscow. He was going back to UK and came through Stockholm. So he was told that the Germans were about to invade Soviet Union. He passed this information on to his Soviet colleagues. But since Stalin didn't know where the information came from, he didn't believe it. There were also, my favorite telegram was about trade negotiations. Because Sweden had quite a large trade with Germany. So the Germans sent a group to Stockholm in December 1941 to discuss trade agreements for 1942. And when they were in Stockholm, they received instructions. And the Swedes, of course, received the same instructions. And they are basically saying that we can accept an interest rate of 3.5%. But if the Swedes really insist on 4%, well, go for it anyway. What do you think the interest rate was agreed, which interest rate was agreed on? Well, this is actually a telegram where you could calculate the value. I mean, what's the value of not getting invaded? It's hard to say. What's the value of knowing how many German airplanes there were in Finland and Norway? It's good to know, but what's the real monetary value? That's hard to tell. But this one, the foreign minister could calculate that it was about, worth about 20 million crowns. And 20 million crowns back in that day would have provided for the annual budget for FRA for more than 11 years. My cryptologist colleagues, they tend to change the subject every time I ask them how many annual budgets they have saved in the recent week. So this is the final picture of the Geheimschreiber. You see the wheels up on the top. And behind the locked little compartment, there was the wiring where you could change the ordering of the wheels. The machine was constructed in a way that made it easy for the operators to make mistakes. When you set the daily key, you could put in a hatch on each wheel, so you could reset to that position. But the operators tended to put in the hatch on all the wheels. So because if you get out of sync, then you have to resync in some way. And the correct way to do it is to agree on a position further in the key stream. So if we start somewhere and along the way we get out of sync, you should say, well, let's go to the millionth character in the text and sync from there. But since it was easy to reset the wheels for the daily key, they used that for all the wheels. So that was why so many so many messages were sent with the same key. And that was about it. Do you have are there any questions or comments? No?
Thank you very much, Vesa.
Thank you.
Like you said, it's the latest thing you can talk about.
Actually,
now there was something later.
There was something they called the Lorentz machine, which the Anglo-Saxon called Tunny, which we also broke. We didn't have as much production on that one, but that was the machine which made the Brits build the Colossus. So we have a really cool machine at our museum where they have also built a mock-up of the machine without knowing how the machine actually looked. So it's bicycle chains going. You have seen it, maybe?
I've actually seen it. I was going to say, can anybody come to that museum?
Somebody can come to that museum, but not just anybody. During the pandemic, we have shut down all extras. Yeah. So we do production as normal, but we don't do any museum tours or something.
All right, but normally, how would you?
Normally, I mean, last year at SICT, we invited some from the audience, or actually people from the audience could enter a raffle, and then it was like 20 or 30 persons who were invited to our headquarters and where we had a museum tour.
Well, next year COVID is over, so do
yeah,
that again. Do that again.
We decided not to do that this year, but next year, absolutely.
It's a lot of people that want to see it.
Yeah, I mean, it's a cool museum.
No. Well, thank you, Vesa.
Thank you.
Thank you very much. As of now, since this is the final talk, speaker feedback is open at this QR code and the URL that you see. So this is also new for the year. So just go in, you can vote anonymously. Also this is important for...
Do you vote anonymously?
What?
Do you vote anonymously?
Yes, but only once.
How can you control for that?
Well, we have logs.
This is a new app. I mean,
this is a new app.
I'm not sure if I trust that, but okay.
But
please only vote once.
Please only vote once. And it's important for the speakers and for us to see what content you like, and also the best speaker gets an additional
€1,000.
An additional €1,000 in pay. So. And also, I want to thank everyone for this. Do we have the other presentations?
We don't have an exit presentation this year. It's.
So then I really want to thank everyone for coming and making this possible. It's been super fun to do this. It's been super challenging to do this with the COVID rules this year. but everyone have been really neighborly, and I think everything has worked.
Can we get all the organizers on stage? We usually try to get all the organizers on stage.
Everyone up on stage that's been involved in the production.
This is unorganized, I'm sorry. We can organize everything but ourselves. It's like herding cats here.
So, and I really want to thank the stream team as well that's been doing all the awesome work in online productions. And Hannah, who's already left, she was so exhausted, but she's been doing all the almost impossible flight bookings and getting everyone in through COVID. And also, I want to thank Seconds Podcasten, who has been doing the interviews with everyone. They have sort of left already, because I have a feeling this year...
There's some still here, and I think they're also interviewing someone, right? No?
So yeah, a big round of applause for everyone making this happen. And as every year, I'm still going to ask, Secti is a non-for-profit, but we do like, if you feel like, yeah, this is a good thing, I want to work really hard for free, for just the glory. Please come up and talk to us. We do need more hands, and we will take all the hands we can get. So if you want to get involved with the great team, don't hesitate to shout out to us. Thank you very much.
And I guess the videos will be online as soon as they can be online. It's like, don't stress yourself out, but people will start asking, where's the video, where are the videos? Like,
and we will have to render all the videos from like high-res stuff to get it to YouTube. There will be talks, but they won't be up this weekend. We now everyone deserves a bit of rest.
Yeah.
So thank you very much, and I hope to see you back next year. And also there will be a spring pub if we don't get another COVID variant and can't do any.
Yeah, no, COVID's over now, right? The restrictions are going away. Next year we're coming back with 2,000 people in this venue. Should it be fine? Is that okay? Awesome. I think we should be able to put in 2,000 people in here. But stay safe and stay healthy until then, okay? I don't want to hear anything about a COVID wave because of this. All right. All right, thank you.